A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm. Thank you. So, hello, a very warm good morning to all of you, and welcome to Baiju's Exam Prep IAS. Welcome to another session of geomorphology, where today we shall be proceeding ahead with the portion of the volcanic landforms, and we shall be moving to the portion of the other endogenic forces which act and create the different types of folds and rift valley structures, what are the different types of folds which get created. So that is something that we are going to cover, and then we are going to move into the portion of the exogenic forces which act on the surface. Now, what is it that we studied yesterday? So yesterday, basically, we initiated the discussion again from the global distribution of earthquakes. Then we moved ahead and understood the Indian aspect and the probability of earthquakes occurring in different parts of the country, the zonation from zone 2 to zone 5, which has been done in the rest of the country, in order to understand what is the probability, what is the frequency with which the earthquakes keep on occurring in different areas. We also observed how is it that induced seismicity can be observed, or how is it that you can have an earthquake experienced by the activities of us humans. So, be it the construction of dams, be it mining activities, or even, for example, hydrocarbon extraction, these can also lead to induced seismicity. Then we observed volcanoes, what volcanoes are, why is it that volcanoes do erupt in different parts, and the types of volcanic landforms based upon their features, based upon their properties. And then were discussing about the aspect of these particular intrusive volcanic landforms. Intrusive volcanic landforms, basically, when you have certain materials or molten materials which cool down in the interior of the earth structure itself without breaking through the surface. Now, it is in those interiors where they cool down and they form those intrusive igneous rocks. They are referred to as intrusive volcanic landforms. Okay. Now, here we had looked at the batholiths as an intrusive landform. So batholiths, when we basically discussed that when the entirety of magma chamber in itself undergoes solidification, the entirety of magma chamber in itself cools down and then forms a larger igneous rock formation. That is a batholith, right? Now, we will take a look at the other different types of intrusive landforms which are also created. So we'll take a look at laccoliths. Now, laccoliths, what are laccoliths? So laccoliths, basically, they are such kind of formations where material from the magma chamber has tried to come out, but then it has accumulated somewhere within the region of the Earth's crust in a manner of a dome-like structure. So here, it happens where, let's suppose, if we build the magma chamber first, let's suppose this is the magma chamber, and through the magma vent, maybe the materials have tried to come out, but then there would be a hard structure of rocks, and the materials would have solidified there itself, raising that portion of the crustal layer. So, this solidified form, this is what is referred to as laccolith. So, as we discussed yesterday also, most of this classification, or in fact all of this classification, is done on the basis of the shape, the size in which that solidification is happening. That is the determining factor. So laccoliths, they are large dome-shaped intrusive bodies with a level base and linked by a pipe-like channel from below. This is your pipe-like channel, which would basically connect it to the magma chamber. Understand, if the entirety of magma chamber would have solidified, it would be a batholith. But here, the entirety of magma chamber is not solidifying. above it, materials have basically concentrated in a region and they have solidified in a, again, dome-like structure. So observe here, this is the portion of your laccolith. Now, over a period of time, the top surfaces will be removed, will be eroded, will be weathered, and this dome-like structure will be exposed to the outside, and eventually this will give you an appearance or a look somewhat like this. So you can think about it that at one point of time, this would be a region inside the surface of the planet Earth, hence intrusive landform. Now, furthermore, we also have a lopolith. Now, a lopolith, the shape is different and in fact slightly opposite to that of a laccolith. In a laccolith, what is the shape of that landform? It has got a dome-like structure. In a laccolith, the dome-like structure that is created. So you have a flat base with a kind of a convex top. That is the case with laccolith. Okay. Lith here refers to rocks. So wherever you come across the term lith, it basically refers to the term rocks. Okay. So laccolith will have that kind of a shape with a flat base and a curvilinear top. Whereas when we talk about a lopolith, lopolith will have a flat top and a shallow convex base. So if you can think about it, so this will have a shape somewhat like this. Okay, this will be your lopolith. Yes, a bowl shape. Okay, so it will create a bowl shaped of landform after solidification. That is your lopolith. But it is not always the case that all these molten materials, they will end up solidifying in large chunks. Sometimes it can also happen. For example, let's suppose when we talk about the crustal structure, let's suppose within the crust there is folding which is observed between the rocks. Let's assume that the rocks that we encounter, they have a kind of a fold like this. Now, the molten materials, they will spread themselves within these folds, isn't it? If you have a folded structure like this, a folded structure which is like this. Now from here, if the molten materials are trying to come out, let's suppose, but if they are unable to break through the surface, they will spread out in these regions. Here they will spread out. Here they will concentrate and accumulate. Right? So when they accumulate in those particular folds, then they basically again gain a curvilinear shape and they are referred to as phacolith. So here, whenever the crustal region experience a kind of a fold. So for example, assume that this is your crustal layer. Okay. And here, you have the rocks which are a bit compressed. Now, if you observe the formation and the solidification, if the solidification has happened here or here, again here, so they will gain a kind of a curvilinear shape based upon the shape of the rocks within which they are spreading over. So that is what is a phacolith. So phacolith is a wavy mass of intrusive rocks found at the base of synclines or at the top of anticlines in the folded igneous region. So what is anticline and syncline? We'll take a look very momentarily into it. But just to give you an idea, for example, if let's suppose there's a folding in the rocks, let's suppose the rock is getting compressed and there's a folding happening in the rocks. So the uprised portion, the elevated portion here that you are able to see, that is referred to as an anticline of the fold. And the depressed portion that you are able to see, that is referred to as the syncline. So in any kind of a fold, this will be referred to as an anticline. And this is what will be referred to as a syncline. Right. So these structures are created when you have magma or molten materials, they accumulate in the synclines or the anticlines, and there itself they solidify. So they have a definite outlet to source beneath. So they will have a connectivity to the magma chamber, maybe underneath them, from where the magmatic materials would have come out. So this is the accumulated structure, where you can observe that the magma is solidifying. The magma has been solidifying. And then you have sills and dikes. Now what do we mean by sills? So oftentimes these molten materials, they spread themselves within layers in a horizontal manner, right? In between those layers, they will spread over. So when they spread over in a horizontal manner, and if they have a thick formation, they are referred to as sills. But if they spread between the layers and very thin horizontal formations are there, they are referred to as sheets. So sheets are the thinner version of sills. So sills, basically here observe, this would have been connected to the magma chamber. Now it spreads itself between the various different layers of rocks. The magma spreads itself. Now sometimes it will also spread itself within a very thin sheet-like layer. So when it is very thin structure, it is a sheet. When it is a thicker structure, then it is referred to as a sill. So the near horizontal bodies of intrusive igneous rocks are known as sills. So if you take a visual look at it, this is what a sill will appear to look like. This is your sill. So here you observe that there is a significant layering which is present here. In between the structure of the rocks, there is a significant layer which is prevalent. So that is what a sill is referred to. If this would have been very, very thin structure, it could have been referred to as a sheet. Now, these sills, they are always visible in older volcanic regions, older volcanic areas where you would have had experienced volcanic activities previously. So there you will always experience the presence of these sills. These sills, by the way, sometimes they are super enriched in minerals, because these igneous formations, as they solidify, they will solidify the minerals which they carry as well. So oftentimes they are also abundantly rich in minerals. But sometimes, as these molten materials are trying to come up, they will solidify in vertical columns. In the case of sills, they are solidifying in horizontal row-like pattern. But sometimes they will solidify in the vertical column itself. So when they solidify in the vertical columns here, they solidify in the vertical columns here. They are referred to as dikes. So here, these are known as dikes. So wall-like formation of solid magma, oftentimes vertical. So when the magmatic material cools down in a vertical column as it tries to emerge, it is referred to as a dike. So these are your various different intrusive landforms. Now the question which can be framed from here will mostly be match the following, where a name will be given and the property or the shape will be given to the next of it, and you will have to match. For example, cooling down of the magma chamber, batholith. For example, cooling down in the form of large domes uh, above the magma chamber with a connectivity from the magma chamber, that is what is laccolith. When they cool down with a flat base and a convex bottom like a bowl shaped structure, it is lopolith. When they cool down within in a wavy structure between the anticlines and synclines, it is phacolith. When they cool down in a horizontal manner, it is sill. When they cool down in a vertical manner, in a vertical pipe like structure, it is known as dikes. So, depending upon where they have cooled down and what is the shape that they have accrued after they have solidified, so that is the criteria or the classification which is used to basically talk about all these different types of, or understand these different types of intrusive landforms. Okay. Now, after this, we come to the physicochemical control on the eruption style. Basically, the concept is that when you have an eruption, a volcanic eruption, the magmatic materials, they will have a flow pattern to it. We have discussed about the viscosity aspect. Viscosity of a liquid refers to what? Its ability to flow, the ease with which it is able to flow, right? So you will find that you have different types of composition of magma. Depending upon the chemical composition in the sense the chemicals which are found to be present here, depending upon that, the flow is determined. For example, if you talk about mafic magma, now, mafic magma, the name is accrued from Ma, which stands for magnesium, and Fic, which stands for iron, ferrous. So, here this is abundantly rich in iron and magnesium. Close to around 50% of the proportion of these magmatic materials would be included of iron and magnesium, very low in silica content. It flows very easily. Okay, so it tends to flow very easily. It is poor in silica content. It is rich in iron and magnesium. Okay, now this is going to have a darker appearance when it solidifies. By the way, this is also what is referred to as sometimes as the basic magma. So, in terms of acidity and basic nature, it is referred to as the basic magma. Now, this will have a darker appearance, a higher density. So, the rocks formed will be generally heavier, right? So, here it will have higher density. And then it will also have a kind of a darker appearance. Flows very easily. Okay, it tends to have a flow which is very it tends to have a flow which is very similar to that of water. So that is why it is one of those magma which is in a way always having a kind of a fluidic flow, and a spread over a very large area can also be observed, can also be experienced in this particular case. Okay, now then you have the felsic magma. Felsic is the one which is rich in feldspar and silica. Here the silica content is very, very high. This is also what is referred to as acidic magma. So silica content is very high. Is high. Here, generally the magma will be viscous in nature. That is, it doesn't flow very easily. It will form large blobs out there, right? Large chunks out there. Even in the molten material, it will give you that chunky appearance. So it might also trap a lot of air in between them. Here, in the case of mafic magma, not much air or gases are trapped in this. But in the case of felsic one, you will have a lot of air which is trapped into it. Why? Because as it forms various different blobs or chunks, air penetration will happen, and you will have larger chunks consisting a lot of air bubbles into it. So that is why here you will have a lot of gases contained in the magmatic materials itself. Presence of gases is high. Now, then after that, here magma is viscous, and doesn't flow easily. Okay, it is significantly viscous and doesn't have the flow associated that you have with the mafic magma. Now, upon solidification, it will form materials of lesser density and which are also slightly lighter in appearance. In terms of the visual appearance, they will be lighter in color. The coloration will be slightly brighter. Okay, so here you will have, upon solidification, less density and then also light color rocks. Now, as you can see, the chemical properties of the magma, the chemical composition of the magma in itself, that will basically define the property of the magmatic materials as they flow, what is the temperature that they need to attain in order to melt, and so on and so forth. So here we can also have a conclusion that whether there will be an explosive eruption in this case or a non-explosive eruption based upon the property of the magmatic material itself. Now, if you apply your logic here, where do you think an explosive eruption will happen? Felsic or mafic, or in case of both of them? Where do you think the eruption will be more explosive in nature? Very good. It is basically felsic, because here it exists as large blobs or chunks having lot of various different air bubbles etc penetrated into it. So that is why here, and the gas presence is also very high, so when they will try to come up, there will always be an explosive eruption, whereas in the case of mafic you will have an effusive or a non-explosive eruption. So felsic is always associated with explosive eruption. Okay, whereas mafic would be associated with non-explosive or effusive resistance eruption. Dunesh, is density not proportional to viscosity? Not always. Not always. So in most of the cases it is. But imagine a liquid where you have lot of air bubbles which are trapped within it. Then the density will be low, isn't it? But will it flow easily? If you have large blobs of air bubbles trapped within it, will it flow easily? No, it won't. As compared to a material like iron magnesium, which melts and forms a kind of a liquid flow. If you have a lot of air bubbles which are trapped, it won't have that flow. So viscosity is going to be significantly higher, but the density is going to be lower. Okay, generally when you try to imagine it with the case of, let's suppose, honey or water, honey will have a greater density, hence a limited flow pattern, but that is not always the case. Here you have molten materials which are going to solidify. So these molten materials, when they form large blobs of air etc, so if you have, let's suppose, a particular section of liquid magma which has got these many air bubbles trapped, so what will be the density? Very low. But along with these air bubbles, will it be able to flow on top of each other? Let's suppose another fluid material or another felsic magma, again having lot of air bubbles. Will it be moving on top of each other easily? No, it will take its own good time in order to flow. So that is why felsic magma, despite having a lower density, will have a high viscosity. Okay. I hope that is understood, Dinesh. Can we draw these as examples of intrusive rocks? Which one? Will mafic create shield structure? Many of the cases, yes. Many of the times. Conical structure is created by felsic. In most of the cases, yes. But sometimes, for example, in stratovolcanoes, you will have both these structures getting, or both these eruptions happening. Let's suppose 100,000 years from now, 100,000 years ago, you might had a mafic explosion somewhere in the region of Mount Fuji. Now, it might happen that now, if the eruption happens today, it might be felsic in nature. Right. So in the same region, you will have both mafic and felsic. So that what creates composite volcanoes or stratovolcanoes, which are so very large in size that we have seen. Due to the volcanic eruption, the soil in the nearby area also gets degraded. Yes, sometimes they do. And Subramania, in the outer side of the Arch of Islands, is mafic eruption is present. It is not always the case. It is not always the case that you will only have mafic eruption in a certain region, but generally what happens in the region of the island areas, understand there is one oceanic crust which is subducting somewhere. Oceanic crust generally is rich in what? Basaltic rocks, which are again mafic in characteristic. So that is why you will have mafic eruptions, but then there are exceptions to that as well. Sometimes I don't want to take you into that greater depth where you find yourself to be, if you find it very difficult to extradite yourself from. And also, I don't want you to have that grievance that rather than general studies, he is taking over the optional paper. But just to give you a brief idea, let's suppose there is a kind of an oceanic crust here, okay, which is undergoing subduction across a continental crust, let's suppose. Now, as this is undergoing subduction, while some of the sediments, etc., will go along with this oceanic plate, but many of these oceanic sediments, they will also get accumulated as the remaining portion of the plate undergoes subduction. So some of that sedimentary portion, etc., let's say it gets accumulated. Now, what are the sediments composed of? Sediments or sand particles, silt particles, etc., that you observe, what are they composed of? Silica. Silica is abundant in them. So let's suppose there is, over a period of time, there is that kind of subduction where even these materials, they undergo subduction. So as long as only the crustal layer was undergoing subduction, you would have basaltic magma which would have come up, right? But as soon as this sedimentary portion undergoes that subduction, you will have felsic magma which will come up. So it is not always the case that only one kind of magmatic material will be thrown out from somewhere. It depends that where that magmatic supply is coming from. Okay. Generally, when you will come across the volcanic hotspots where the molten materials are consistently being provided from the lower portion of the mantle. Now, in the lower portion of the mantle, when you are closer to the core, which will be more dominant, silica or iron? What do you think? In the lower portion of mantle, which will be more dominant, silica or iron? Iron, right? So if there is a mantle plume somewhere and there is a volcanic hotspot created, so the magmatic material will be rich in iron. It will be mafic magma. So that will have a flow pattern associated. That is why in the region of volcanic hotspots, you don't come across explosive eruptions, right? So that is how it changes. It changes from one region to another. Biswajit, only crust undergoes subduction? No, it is the lithospheric region which undergoes subduction. Uh, so, Subramania, I hope that portion is understood. Kuraku, you are correct. And Nirikshit, the rocks present in picture, those are also created due to volcanic eruption. Which picture, my dear friend? Are you talking about this particular picture? Yes, these are basically the magmatic materials. Sandeep, are you in Bangalore? Yes, my dear friend, I'm in Bangalore. Okay, so that is basically about how the based upon the characteristic of magma, we can come across or we can decipher whether the eruption will be explosive or non-explosive. This is a particular chart which will be helpful for you to revise this concept only for your prelims perspective. So use this for your revision for the prelims perspective. Okay, because in prelims, the pattern in which the UPSC is asking questions, UPSC can always frame a question like this, that whether it will be or whether the silica content is high, whether it will be fluid or viscous in nature, etc., whether it will be an explosive eruption, non-explosive eruption. So such kind of questions can be asked. Such questions, the candidates who are serious in terms of your serious competition, those who are going to appear in the mains examination with you, so they will not commit mistakes in these questions. You will have the non-serious candidates who will always commit mistakes, but that is not your competition. That is not the candidate that you have to worry about, that that person has not read, so I will also not read. No, the serious candidates do read this, they do come across this. So ensure that in these areas, particularly in geomorphology, you have to ensure that these are low hanging fruits. There is not much innovation that UPSC has done in terms of the questions that it is asking in geomorphology. In all fairness, it is basically utilizing the same questions over and over again in geomorphology as well as in the portion of oceanography. But when we discuss the previous year questions, you will get an idea about it. So here, observe, if the silica content is close to 50% or less than that, it is a mafic magma, right? Now here the viscosity is low, it flows easily, hence the gas content will also be low. So it would be a non-explosive eruption, right? It would flow easily. If the silica content is very high, close to around 70% or more, so that is your felsic, right? And here the viscosity is high, it doesn't flow very easily because it has a lot of gases which are trapped in between. So that is why for this kind of an eruption, you require an explosive eruption to happen for the expulsion of all the materials. Okay, right? Laccolith solidifies in portion of crust mostly. Mafic is basic, felsic is acidic. This is acidic in nature. Okay, that is your magmatic material which is acidic in nature. Now, the distribution of volcanoes across the globe. Now, here also you can get a question in the mains examination. This is relevant for your mains exam. Okay, just like in the case of earthquakes, here also you can expect a question that discuss about the various different or the global distribution of volcanoes and talk about why these eruptions have happened in various different places. Such kind of questions can be asked. For example, last year UPSC had framed a question that discuss about the volcanic eruptions which have occurred in 2021 and why they have occurred. Now, here, do you think that UPSC is expecting you to enumerate all the eruptions which have happened in the entirety of 2021? Obviously not. The major eruptions, Iceland, La Palma eruption, then you had the Tonga eruption. Because Tonga eruption was so much in news, so that is why UPSC wanted to test the candidates whether they are aware about it or not. So in that case, here also you can go for the zonation, that you have certain zones where these eruptions are very, very common. So for example, when we talk about the zonation of these volcanic distribution, one is the Pacific Ring of Fire. Pacific Ring of Fire. All around the region of the Pacific, you do have periodic volcanic eruptions which keep on happening from time to time. So that Pacific Ring of Fire, you will experience volcanic eruptions. Why? Because there is some or the other form of subduction which is happening, convergence which is happening, either oceanic convergence or oceanic continental convergence. Some or the other form of convergence is happening due to convergences. convergence. And then you will also find volcanic eruptions to be happening in the region of Mediterranean, right? Where you have Etna, Stromboli, Vesuvius, volcano. All these are to be found in the region of Mediterranean to the southern portion of Italian coastline. Why is it that eruptions happen here? Again, you have subduction. Subduction, as the African plate is moving northwards, it is the oceanic crust of Mediterranean which is undergoing that subduction. And subduction where? Underneath the Eurasian plate. And that is why in this region you will have volcanic eruption. So, Mediterranean. Convergence of African and Eurasian. Now, Tonga eruption that we talked about, Tonga eruption happened here, right? Now, this was so very massive. This eruption was so very massive that the shock waves created traveled across the entirety of the planet twice. Think about it, that our own meteorological department weather station, which is situated in Goa, that experienced a sudden change in atmospheric pressure due to the shock waves which were emitted by the Tonga eruption, right? So, other than that, you had a very massive eruption in 1991 in the region of Mount Pinatubo in Philippines. Then here you have the Krakatau eruption, which is situated in the western part of Indonesia, and this is supposed to be one of the most massive eruptions in the past 200 years or so. That Krakatau eruption is one of the most massive eruptions which have occurred in terms of their force. It is said that the shock waves again could reach very far away regions as far as Japan and Turkey, and the amount of dust, the amount of smoke which was emitted, it blockaded the sunlight in that particular area for almost more than a month, right? So you did not have any sunlight penetrating that region because of that huge amount of smoke. It is also said, as we discussed yesterday, that the amount of carbon dioxide released into the atmosphere during the Krakatau eruption, that it is said to be taking close to 200 years for that carbon dioxide to be digested into the atmosphere. Okay, then you have the mid Atlantic ridge. Mid Atlantic ridge. That is because why? Divergence. So, where do we experience, for example, have you guys followed the current affairs about what is happening in Iceland? I'm sure you would have followed it, given how pertinent and particular you guys are with current affairs. I am sure you would have followed what is happening in the region of Iceland. Iceland has experienced over the past week close to around 900 earthquakes, right? Not very high in terms of magnitude, low magnitude earthquakes, but 900. And there is a volcanic eruption which is brewing up in various different parts. And that is because divergence of plates. Why? Because that is the region of Iceland lies on the mid-Atlantic ridge. So as the North American plate is moving away from Eurasian plate, you will experience these volcanic eruptions happening in these areas. Right. So do follow these current affairs, guys. Okay. And try to link it with the static portion. Many of the candidates I have seen that while they are studying the static portion, it is with a very kind of a closed mind that, okay, this is somehow I have to rectify, somehow I have to mug up. Let's only concentrate on this. And if there is an event like that in Iceland, suddenly they are curious that take a separate session for the volcanic eruption in Iceland. But in reality, you don't need that for you. You should have that conclusion making ability on yourself that, okay, I have read the divergence of plates, I have read the convergence of plates, I have read the transform movement of the plates. So there is no reason why I should not be able to account for why a particular volcanic eruption is happening. Okay, presently you guys are in that position where you can give reasons or understand the reasons why anywhere across the world you have volcanic eruptions which are happening. Okay. Now, other than this, areas where you will experience volcanoes frequently, that is your hotspots. Volcanic hotspots. Example, Reunion Islands, Hawaiian Islands. Even Aleutian Islands you can consider, but these are your regions where you will experience these volcanic eruptions. Can we consider the Iceland earthquakes as foreshocks? No. They are put into the category of earthquake swarms. Swarms of earthquakes. Swarm means what? You use the term swarm when you say that a swarm of bees invaded my backyard or the vicinity. So, what does that mean? Basically in large numbers. So when you have these almost 900 to 1000 these small earthquakes which are happening, none of them in major magnitude, so you refer to them as earthquake swarms which get created. Okay, right. And Yogi, can there are there any volcanoes be in India and Africa, as India is moving away? India has got an active volcano. And what is the name of that active volcano? Barren Islands. And the last eruption happened in 2017 almost. Africa, it is having the volcanoes, but not many of them are active now. They are in Most of them are in dormant stage. One or the other active volcanoes are present, but not in significant frequency. Okay. During lightning, okay, during volcanic eruption, is lightning happen? If it happens, what is the cause? Lightning does happen when you have a volcanic eruption. That is because so many dust particles they are emanated into the atmosphere. So it is within those dust particles that a charge is gained. When we talk about lightning, furthermore, once you understand the basics that why lightning happens in the first place, you will be able to understand that also. So wait for some time, but it does happen. And this map, how to understand? Are you not able to understand this map? Is this map difficult for anybody? Okay. Hmm. Maybe we are used to different types of maps. So this is your Pacific Ocean. This is your Indian Ocean. This is your Atlantic. This is where you will have the mid-Atlantic ridge, right? These are where your hotspots will be. Okay, this is again a Reunion Island hotspot will be situated somewhere here. So this is the region of Mediterranean where again eruptions have happened. This is a plate-wise description. If you are comfortable with this particular plate or this particular image, you can use this also for your understanding. So at the plate boundaries, you will observe this kind of an eruption. Okay, right. And why UPSC wants us to know about this? Right. See, the reason why UPSC wants you to study geography, ideally, what the expectation of the candidate is when they think about civil services, they think that okay, I will be dealing with the district. Eventually, I'll be dealing with the chief minister. Then I will be dealing with the prime minister. So they will tell me that okay, uh, XYZ, what is your name? Whatever is your name. So let's suppose Rohit. Okay, Rohit, do one thing. You take care of this particular district. You solve all the problems of this district, but you have to understand, once you get deployed at a district level, the problems that you face are not in the case that how prime minister or chief minister, they will never even get in touch with you, right? Even chief secretaries don't get in touch with you once you become an IS officer. Very rarely will they get. But when you solve problems on the ground, what are the problems on the ground? Lack of water supply for irrigation, right? Lack of economic opportunities in a particular area, the soil is not quite fertile. Now, why is there a lack of water supply in a region? For example, when you come to the region in southern part of the country, water supply is very scarce. Unless and until you understand the rock types, or if you have some clue about the rock types, rock patterns, etc., you can easily have a contractor come to you and say that, look, sir, this is the rock where we will find oil. So give me that much amount of money, I will dig oil out of it. If you have a basic common sense, you will understand that there cannot be oil here, right? So that is why concept of geography is important, and all these concepts help you understand India better. For example, when we consider the region of red and yellow soil across the country, so if let's suppose you are posted in a district where you have a red or yellow soil, now there the organic content won't be present in that soil because it is made out of igneous rocks by ancient volcanic eruptions. So you would get an idea about the property of the soil also, if you are aware how that region was created, how that region came into existence. For example, when we consider the region of the Deccan Traps, the region around Maharashtra, etc., now you have thick deposits of lava which have solidified in various different layers. In between those layers, you have water which is trapped, and that is used as extraction purposes, for irrigation, etc. So that understanding is what UPSC wants you to have. But then again, I'm not going to justify the very weird type of questions that UPSC asks. Understand, this is an examination where it wants to check your accumulated knowledge, right? What is your accumulated knowledge till now? What they are trying to find, I hope you are able to understand what they are trying to find and select at the end of the day, is those people who are going to be decision makers about the future of the country. Those people who are going to be decision makers in terms of how the policy framework is brought out, right? So that is why they need problem solvers, and that is why they frame the questions in this way, they talk about the topics in this way. Because for a long period of time you had a trend, I don't know if I've talked about the trend of the examination with you guys. I did talk about it in the first class, but if you observe the trend, UPSC has shifted the type of questions that it was asking. Earlier it would be asking questions which were directly taken from the books, so people would devour all the books. But now, try to find the books from where the question is asked. Maybe you will find one book which has mentioned a topic, another book which has mentioned another topic. So obviously, you won't be able to read 100 different books, right, for the course of your examination. So it wants you to think on your feet at that point of time and then arrive at an answer. And I think many of us, we need to also have an idea about what the job of IS officer or a bureaucrat is. Most of us, we see on social media about the entries that they take and the large cavalcade that they have, and we think that, okay, there will be the prime minister, I will be here, together we will take the country forward. But that is sadly not the case. Now, see, I'm trying to answer all the questions, so please don't push the questions. That please answer my question. All the questions I'm trying to answer. Okay. Please tell, okay, what is that question that you have been stressing so much upon? Please tell one thing. Okay, what is that one thing? That our first attempt is in 2026. So are we needing to follow current affairs or newspaper from now? Absolutely and invariably, yes. As prominently as I can tell you, yes is the answer. If you are going to appear in this examination for 2026, 27, 28, 2050, 2100, next century, wherever you are going to appear, whenever you are going to appear for the examination, if you have made up your mind that you are going to appear for the civil services examination, newspaper reading should be initiated from today. And that is where I talk about the residual information and residual knowledge. Okay. In between the Nazca and South American plate, can we consider example as a volcanic eruption? Yes. Here, I hope you are talking about Subramania. Here you have a lot of volcanic eruptions which happen. That is where you have a continental oceanic convergence. Shreyas, how does a magma get converted into felsic or mafic? So that is what I had told you, Shreyas, that it is not the case that a magma is present, molten magma is present, and it will suddenly turn felsic. and suddenly it will change color and it will turn mafic. No, it does not happen. But how is that magma generated? Think about that. How is magma generated? In many of the cases, the volcanic eruptions that we observe is because of subduction. Somewhere or the other, there is subduction which is happening. Now, if there is subduction of, let's suppose, the sand particles, etc., which is happening in greater propensity, there will be felsic creation, right? Felsic magma will be created. If only the plate portion of it, the crustal portion of it, that is subducting, in the oceanic case, then you will have a kind of a felsic magma or a mafic magmatic creation. So depending upon how that magma gets created, for example, in the case of mantle plume, you have magma getting supplied from the lower portion of the mantle, so that will be always mafic in nature, rich in iron. So that is how you get an idea about it. Okay. And are there volcanoes and oceanic ridges between North America and Greenland? There is an oceanic ridge, but it is not so very predominant. The most of the oceanic ridges that you find are present here in this area. Here you don't have much, but it will come. It will come. There is a propensity of this expansion happening as well. Okay. How to find which plate is convergent or divergent? When you read enough number of times and take a look at the map that I have provided to you in the previous module, that will give you enough idea. Okay. Sana, okay, last couple of questions I'll take and then we will move forward. Sana, how should I select my optional? I am appearing for in 2026. So do I need to choose optional now? Year after 1 year. Cover the basic GS now because you have time, then choose the optional. And about how to select an optional, we conduct periodic workshops. I myself take many workshops online also. So do attend any of these workshops where we talk about how to score an optional, what is the things or the ideas that you have to keep in mind in order to take an optional, which optional is better based upon your ability. A lot of things come into the picture. If my graduation background is very, very strong, where I've studied a subject that I'm very good at, it makes sense to take that on optional. But if my graduation background is something different, I'm not interested in that anymore, take another optional. So it depends on many of those variable factors. Attend any of those workshops that we conduct periodically, you will get an answer. And you will get the notification whenever we take a workshop, whenever we conduct such a workshop. We generally do conduct it on a monthly basis most of the times. So either I will be conducting the workshop or Sarmat sir will be conducting those workshops. You will get a notification about that. Don't worry. And Biswajit, the Hindu newspaper articles that you cover in YouTube are different from the Hindu paper in my locality. Many articles are not. Don't worry, cover them from the portion of the YouTube in that case. But at the end of the month, you have to revise with the monthly magazine. That is your mode of revision. Just looking at the YouTube, that is never going to. And please understand, guys, this is where I I have to tell you. Please understand, newspaper is not for your only for your current affairs. If only current affairs was the key to be extracted from newspaper, then why would you read newspaper? You have so many monthly magazines by so many different institutions out there. So many different coaching institutions are there. They provide you with a monthly magazine. Why do you need the newspaper then? Understand the purpose of newspaper reading is much larger. Okay, as a candidate, this level of maturity is something that I seek out of you. You should have that understanding that why someone is pushing us to for newspaper reading, because I also know, I from my own personal experience will vouch for it, that just staring at the screen and understanding and analysis is much easier than going through the text of the newspaper. But that reading, the more you read, the better you write, right? So many of you, when you come over and you say that my answer writing is not good, I'm not able to create good answers, I know the concept but I'm not able to frame them. Why? Because your writing skill has not been developed. Why? Because you have not read so much. And by reading, I don't mean that reading Lakshmikant, reading the NCR. That is not reading aspect of it. That is where point-wise matter is pasted in front of you and you simply have to mugify those parts. So that is not reading. When you read a book, When you read particular novel, when you read a newspaper, when you read a magazine, that is where your comprehension ability increases, how you comprehend, and that is where your ability to reproduce them also increases. That is why reading is important. It helps you understand how to be masterful in terms of bringing multiple perspectives to the table at the same time. Okay, and then plus there is an added portion of current affairs also. For example, last year, the entirety of last year, Nagorno Karabakh was not that much in discussion. It was in significant discussion the year before that, right? There was some discussion about Nagorno Karabakh last year also, but not majorly, because the war had grown 2 years older and Russia Ukraine war had emerged. UPSC asked about the Nagorno Karabakh portion. UPSC asks many questions. For example, Reporters Sans Frontier, right? Or Doctors Without Frontier, Medicine Sans Frontier. What are these? Where do you get the idea about these questions? From the newspapers, right? When you read the newspapers, that is when you gain an idea. Amongst all the larger article, maybe a line would be hidden somewhere which will enlighten you. So that is why, if you are serious for the examination, and trust me, ask any of the people who have succeeded in the exam, have they done it without newspaper reading at all? I don't think you will find anyone. If you find, please point that out. And magma is generated due to residual heat or not? So Santosh, residual heat is there, but along with that, you also have the radioactive materials present in the region of asthenosphere that also ends up generating the magma. Okay, and Ziba, can it be concluded that materials subducted are concentrated and don't scatter, and hence when they erupt at a time, similar kind of materials come out? Yes, in many of the cases, yes, true. Right now, we'll come to the other portions of your GS queries and preparation queries later on, when the time allows. Now we come to the portion of folding and faulting. Now, folding and faulting, that is basically the impact on the landmass due to the compressional and the tensional forces. Now, let's suppose we consider a region like this. Let's suppose we consider a small land area. By a small land area, I mean maybe a couple of 100 kilometers wide and longer as well. So let's suppose we consider this area. Now, in this area, if there's a compression which is acting on both sides, right? Now, this is not a plate boundary that we are talking about, but there can be compressional force. Now, in that case, what will happen? This rock structure will behave differently. It might get folded, it might get broken. For example, if I consider a piece of land, let's say a sedimentary plain, which is softer in structure. Now, if I apply the force from both sides, it will get folded, right? But if I consider a piece of land which is made up of very hard igneous rocks, for example, the southern peninsular part of India, now there, if I consider this as an analogy of that harder piece of rock, what if I compress this? This pen that you are able to see in my hand, what if I compress this? What will happen? Will it get folded? No, it will break from between. One portion will simply move over the other, or one portion will simply come underneath the other. That is what happens if you press it continuously, and eventually the cracks will get created. So, folding and faulting that you observe on the land surface is again an outcome of the endogenic forces, the forces which are acting from the interior of the earth. That is what will also lead to folding and faulting events. Now, this is generally because of the tensional or the compressional forces which are acting on the land masses. Okay, tensional and compressional. Kiran asked remind me about that question at the end, and I will take it up. Right now, let's concentrate back on the subject. Tensional forces acting on the surface. Now, here When we talk about folding, what is fold? All of us from our childhood days, we have seen folds. What are folds? We know what a fold is. So when you have such kind of land surface where if compression is applied, let's suppose a compressional force is applied, you will find that the materials, they tend to accumulate. Materials, they tend to accumulate here. This is a fold. Now here, the folds can be of different types. How? Let me tell you. Suppose the materials, they have accumulated, or there is compressional force which is acting from both sides. So that compressional force initially will create this kind of a fold, isn't it? But if you, let's suppose, increase the force from one side, from this side, if I'm increasing the force, what will be the impact of it? Observe this. If I'm increasing the force, observe the nature of the fold. Is the nature of the fold similar as compared to the earlier? No, it is changing. Eventually, it goes, the rock structure can become almost horizontal. But what if the compression continues even after that? The rock might break from here, right? I hope you are able to see that paper. I hope you are able to understand that. So here, basically, always understand that folds are classified based upon their shape and nature. So if you have a fold like this, it tells you what? That the fold is symmetrical in nature, right? Both the arms of the fold, they make the same angle with the central axis. And here you can also think about it that basically this is where the compressional forces from both sides would be equivalent, would be symmetrical, and that is why you have that kind of a fold created. But whenever a fold is created, whenever you have a fold which is created, it will have a structure like this. Now, this is what is referred to as an anticline. This is what is known as a syncline. Okay. The risen portion is known as the anticline. The depressed area, that is known as a syncline. So, folding is a bend in the rock that is a response to the compressional forces. Now, here you have classification of the folds based upon what is the amount of force which is being experienced. For example, initially, again, observe this image only once. Don't read too much into it. Just observe it once. Slowly and steadily, you will understand this image in a greater detail. This I have put into place so that you are able to formulate this and refer to this even at a later stage when we come to Indian geography, when we talk about the thrust faults in Himalayas and the occurrence of earthquakes in Himalayas. You can always refer to this image. It will be helpful. So here, let's suppose you have a rock structure like this. You have equal forces acting from both ends. So the fold created will be symmetrical in nature. And that also tells me, or we can come to a conclusion, that here the folding would have happened quite recently. That is why the fold structure is like this. If the pressure continues, the forces of compression continue, let's suppose, then eventually, let's suppose I have increased the force from this side. As I increase the force, observe this fold. Is it symmetrical anymore? No, it becomes asymmetrical. Then it gets isoclinal. Then eventually, as the compression continues, it will become almost horizontal, right? So that is the basis. So as you go across the rock structures where the compression has been happening for a very long period of time, you will find that the folds are not symmetrical. They are rather staggered, they have a different shape, etc. By the way, many of the times from the surface, you won't be able to distinguish that this region is folded. Many of the times, in certain areas, as you walk over, the ground surface will appear to be very plain to you, right? But underneath, folding would have happened. Why that is the case, or what I am referring to, I will show you with the help of the image also. So let's suppose you have a fold created in the rock structure somewhat like this. Okay, fold created in the rock structure somewhat like this due to compression. Now, over a period of time, this is the fold which has been created. Over a period of time, actions of erosion, weathering, rainwater, impact of it, wind, etc., will level the surface. It will end up leveling the surface. right? So the surface will get created somewhat like this. Here you will have trees, you will have houses, all etc. So if you are living here, you won't realize that you are actually living on a fold. But if you observe the cross-sectional analysis of the rock structure in that area, you'll understand that yes, indeed, the rock is getting folded. So such kind of folds are also present. So fold will happen in those kind of land areas where it has got slight deformation ability. Slightly it is able to deform. If it is not able to deform, it will break. Rather than folding, it will break. But if even if there is a slightest scope for deformity, it will fold. So the classification symmetrical, asymmetrical, recumbent, and nappy based upon the type of fold. Just to give you a kind of an image analysis, symmetrical fold will be, as the name suggests, symmetrical in nature, where on both sides of the axis, the arms will make the same angle. Asymmetrical, which is not symmetrical in nature, again, simple one. So this will be somewhat like this. Then recumbent is where the rock structure, after getting folded, becomes almost horizontal like this, right? And eventually, if the folding continues, it will break from here. The rocks will break from here. And nappy is where what is a broken fold, where a fold simply breaks and then starts sliding over the remainder portion of the rock structure. We'll take a look at each one of them, starting with the symmetrical fold. So observe the rock structure here. On top of it, you have proper forested land. So many of the times you won't even be able to distinguish that, okay, we are standing on top of a fold. But observe here the rock structures, the degree of folding in the rock structures. It is symmetrical, isn't it? So that is where, if the folding has been happening relatively recently, and the folding has been happening with unified or a kind of a uniform force of compression from both sides, you have a symmetrical fold. For example, Andean Cordillera. Now, what are cordilleras? Are we aware about the term cordilleras? Cordilleras basically refer to the series of mountain ranges, which most of the times are parallel to each other, but spread over a very large area. For example, in the western part of North America, also, you'll find Rockies, Cascade Ranges, Coastal Ranges, Brooks Range. All of them, you'll find them. Now, all of them have the same alignment of northwest to southeast in North America, and they are almost parallel to each other, continuing all the way from Alaska into Canada, into US, and then eventually into Mexico, all the way to Honduras, and so on. So that series of mountains, which can spread over many mountain ranges, all of them aligning in the similar direction, parallel to each other, that is a cordillera. So in the region of Andean Cordillera, you will find symmetrical fold. Even for that matter, in some portions of Himalayas also, in particularly the newer portions, for example, the region of Shivaliks, which are relatively very, very young. So in those areas, you'll find this presence of the symmetrical folds. Okay. Now, then asymmetrical folds. So when we talk about asymmetry, here observe this particular fold here amongst the rocks, amongst the layers of the rocks. Observe the fold. Right. From top, it will give you an appearance almost absolutely of a natural manner. But within it, you will find a kind of a varied skewed structure. So that is a kind of an asymmetrical fold. Represents variation in compressional stress from either side. From one side, if the compressional stress increases, you will come across an asymmetrical fold. So in the region of the Himalayas, in many of the portions of Himalayas, you will find this along with the alpine cordilleras, that is around the region of the Alps. There also you will find this. Rockies also you will find this in certain portions. So you will find this in many. In Himalayas, in certain part you will find symmetrical fold also. In certain parts you will find asymmetrical also. In certain parts you will find recumbent also. In certain parts you will find nappy also. So Himalayas, because they have been experiencing different degrees of compressional force in different parts of its location, you will find a variety of the different types of folds created. So asymmetrical means from one side the force applied has increased. If I continue increasing the force from one side, I will eventually attain a horizontal status in terms of the deformity of the rocks, right? So that deformity, that is what is referred to as a recumbent fold. This is also what is referred to as a sleeping fold because of its horizontal nature. So here, observe that the rock structure becomes almost horizontal in terms of the fold that it has accumulated. So here, the axial plane becomes horizontal or near horizontal. This is also known as a sleeping fold. So in this case, it will accrue a shape somewhat like this. Okay, within the entirety of the rock structures, obviously, the rocks will assume a shape like this. On top of it, you might have other rocks which have not been folded to that extent, but this is where you find it. Now, in this case, if let's suppose the compressional force continues to increase, compressional force, if let's suppose continues to increase from this end, it is much more high. Now, then what will happen? In that case, as the compressional force increases, here at the zone where deformation is happening, the rocks are getting deformed quite significantly in this area, isn't it? And we are talking about rocks, by the way. We are not talking about paper which is getting folded. So beyond this, if the rocks get folded, then what will happen? It will break. And as it breaks, the compressional forces, they are acting continuously. So the remaining portion of the fold will start sliding over, right? The remaining portion of the folds, they will start sliding over. So that is what is known as a nappy or a broken fold. So when we talk about nappy, here observe this. Observe the very skewed kind of folds here in all this area. But observe here, there is a broken fold. This is the portion which is broken. At one point of time, this would have formed a kind of a recumbent fold from this region, but that has now broken. So that is where now, as the compressional forces will continue, this will simply slide over the other portion of the fold. Okay, so that is your nappy or broken fold example. Himalayas, particularly the region of Himadri or the Great Himalayas. There you will find the existence or the creation of many of these folds. Okay, I hope that is understood. High intense folding either upward or downward lead to earthquake. It can. It will lead to some shaking in the nearby surface, in the nearby areas, but you have to understand that this folding is happening over a very long period of time, over a period of time of many millions of years, hundreds of millions of years, tens of millions of years. That is the time taken. So maybe every year it is changing by 1 millimeter or even less. So unless and until it breaks, right, or unless and until the rocks they try to regain their own position, then earthquakes will not happen. But if the fold breaks and there is, let's suppose, the broken fold, and then they move with respect to each other, earthquakes will always occur. Okay. And Biswajit, what in case of symmetrical folding, pressure is applied from both sides? It is applied from both sides. Symmetrical folding, always pressure is applied from both sides. So if you think that I'm not applying pressure from here, I'm applying pressure from both sides. So if I don't apply pressure from here, will it be symmetrical ever? Will it ever be symmetrical if I'm not applying pressure from the other hand? It will never be symmetrical. If you apply pressure from both sides, only then will it create a symmetrical fold. Okay. Will it not break? It will not break as long as the deformation stress or the deformation ability of the rocks, it is within that limit. If it crosses that limit, it will break. That is why I have been repeating for the past 12 to 15 minutes that depending upon the type of material, if I try to fold this particular pen, will it get folded? No. If I try to put pressure on this pen from both sides, compression on this pen from both sides, will it get folded? No, it will break. Right, rather than getting folded, it will break because that is the nature of the particle. Here, if I apply pressure, will it break immediately? No, it will get folded. Why? Because of the nature of the material. So, depending upon the nature of the material, the type of rock structure, that determines whether it will break or not break. I hope that is understood now. Do I need to mug up all the definitions? What does your common sense tell you, my dear friend? The folding processes continue always or for a long time. As long as the forces of compression will happen, it will continue. And will all symmetrical fold become nappy by time? If the compressional forces continue, yes, they will eventually. Does the pressure is due to the movement of the plates? Many of the times, yes. Many of the times, because of the heat supplied from the interior, that portion tends to swell up or that portion tends to thin out. So it will apply the pressure in the nearby areas. Is there any chance of earthquake during the folding process? So that is what I told you. So the folding process is very slow. So immediately it won't lead to earthquakes. But then let's suppose there is a breakage in the rocks during the folding process. It can lead to earthquakes always. No, you don't need to learn the fold definitions. If you understand that, then what they are, you'll be able to recreate them on your own, won't you? Okay. I hope that is understood. Now, then we come to faulting. Faulting is development of a crack, but every crack on the ground surface, that is not referred to as a fault. Okay, every crack on the ground surface is not referred to as a fault. So this entire written text that I have given, that will be relevant for your prelims. So here, many of the times when you consider the rock structure, right? Now here, there can be compressional stress or there can be tensional stress. Let's suppose there's a tensional stress. So if consider this pen that I have in my hand. Now, if I start pulling the pen from both ends with as much amount of energy as I have, obviously I don't have that much amount of energy or power. But if let's suppose I had that much amount of it, so if I would continue to pull it up, what would happen? It would break from here, somewhere in between. It would develop a crack like this. Right. So that is a fault. Again, if I would compress this, compress it from both ends with as much power as I can, will it then get folded? No, it will break immediately. Maybe one portion simply moves under the other. As this breaks, maybe one portion will override the other, but it will break. That is also a fault. Okay, so rock layers do not always respond to stress by folding. Okay, and near the surface the rocks are generally cooler as compared to the interior, so under pressure, even under less pressure, they tend to be more brittle, that is they tend to break easily. Colder materials, they tend to break easily. Warmer and hotter materials, they tend to get deformed rather than getting broken. So that is why the surface rocks, they break up easily. Now, a sudden stress on these rocks may reach the rupture point, resulting in cracking and breaking of the rock surface. Now, here, if you consider, not all the cracks which develop are referred to as faults, right? So, if there is breaking of rock without a relative displacement on either side, the crack is called a joint. So, what does that mean? So, if let's suppose I have this as the rock structure, if there is a crack which has developed here, let's assume, due to various different processes, but there is no movement, as in portion A and portion B, they are not moving with respect to each other. So that will be referred to as joint. So if no movement, then it is referred to as a joint. But let's suppose due to this tensional process, there is slight movement where as there that is being pulled apart, there is development of a large crack. And then further pulling apart means, let's suppose one portion simply subducts, right? So what will we observe? As is the case with the African Rift Valley, I had shown you the image, if you remember. So you will observe somewhat like this. One portion has simply sunk down. Right. So that means there's a relative displacement happening in this region. There's a relative movement happening in this region. So this will be referred to as a fault. This is your fault. Movement, which happens. Okay. Now, obviously, this is a larger rock surface. So the entire region will slip almost. So here, where that movement is happening, that will be regarded as a fault plane. That will be regarded as fault plane. Now you have different types of faults also, depending upon whether the breakage is happening due to tension, compression, multiple tensions and multiple compressions. Based upon that, you have the normal fault, reverse fault. You also have graben or rift valleys as well as horst. So here, if you take a look at it, normal fault. What do we mean by a normal fault? So when we talk about normal fault, here, this results from the tensional stress. Tensional as in the forces are pulling each other away from each other. So let's suppose I have a rock structure like this, a larger rock structure. Now let's suppose there's a tensional force which is acting significantly in more power from one side, in less power from other side. Now this will lead to some amount of cracks developing in the rocks. Maybe a crack will develop here, maybe a crack will be formed here. Eventually, as the forces they continue to act, these cracks will deepen, isn't it? And then, as this continues to happen, what will happen? This portion, as it is getting pulled away, will that be pulled away to such a manner that there's a gap in between? No, it will simply start sliding over the fault plane. So here you will have a structure somewhat like this. In many of the parts of the country, when you would have ventured across, you would have observed the regions where suddenly you'll find an elevation or a region which is at a lower portion, right? This is your entirety of fault plane, right? So that is where a normal fault is created. Now the portion which is left over, the portion which is left over, and there is one portion which has sunk down, but there is a portion which has been left over. So the portion which has been left over a period of time, this will get eroded to varying degrees, isn't it? It will get eroded to different degrees. Various level of erosions will happen. So rather than having a plane like appearance, it will have few of the peak like features which are left behind. All the other will be eroded by the wind, river, etc. They will have their activities, they will have their own processes. So that is what is also referred to as an escarpment. The portion which is left behind, that is what is also referred to as escarpment. Okay. Example, Western Ghats. Western Ghats. That is why Western Ghats are not considered to be mountains in itself. They are not considered to be different hill features. They are considered to be escarpments. Right? Many of the times we confuse the portion of Western Ghats that, okay, these are also mountains, but they are not. They are escarpments. That means a substantial portion has actually sunk down in the region of Western Ghats. And that portion is underneath the Arabian Sea and across the western coastline of India as we speak. So that is what has created those Western Ghats. We'll talk about it when we come to the portion of Indian geography. But yes, in these areas where you have that fault plane in existence, there you will find frequent occurrence of events such as landslides, etc. that you will find occurring in greater frequency also. Okay, so normal fault results from tensional stresses in the crust. Tension means it is being pulled away from each other. It produces a steeply inclined fault zone where the block slides down the fault plane due to gravity, creating a fault scarp. So this is your fault scarp. Okay, and that is also the remaining features of it. They are referred to as escarpments. Okay, now after this we come to the reverse fault. Reverse fault, as the name in itself suggests, is because of the action which is opposite to the normal fault. So it is because of compressional stresses. But compressional stresses, we have seen earlier, it can create a fold also. Compressional stresses can create a fold, but compressional stresses in different materials can lead to the breakage of the materials also. So let's suppose again here, let's suppose here, you have a particular rock surface. Now there is a force of compression acting from both sides, acting on both sides and acting from both sides. Now, if it doesn't have the ability to fold itself, what will you find? You'll find here a crack might develop in this region. A crack might develop here also, right? Eventually, as the compression goes further, it will basically be a crack which will continue to happen, which will spread over, right? A large joint will be created, but it is still compression. It is not as if after that crack nothing is happening. It is still getting compressed. So then what will happen? As it is getting compressed, one portion will simply be thrown over the other portion. So you will come across a situation where the landmass will resemble a shape somewhat like this, where one portion has simply been thrown upwards due to the compressional stress. Right. So here, as the larger portion is being thrown upwards, obviously it appears to be defying gravity, because as per gravity things should come down, but here a particular material is being upthrown, so it appears to be defying gravity. It appears to move in a reverse direction, hence the name reverse fault. So it is produced from compressional stresses where the upper block slides up the incline of the fault plane in reverse of the sense of gravity force, where one block tends to move or slide up against the other one, defying or appearing to be defying the force of gravity. That is why reverse fault. This also happens. This is your fault plane here. Okay. Now, if let's suppose we consider a larger rock region, a larger area, very large area, where you have this depression or this compression or tension acting out, but you have multiple cracks which get created, let's suppose. So that ends up creating multiple different faults also. One of them is the graben or the rift valley structure that we have studied. So here, let's suppose you have a larger rock, a very large rock. Now, if there is tensional force on both ends, let's suppose, there might be a crack developed here. There might simultaneously be a crack developed here also. As that tensional force continues to happen, that crack might further deepen. It might reach here. This crack might further reach here, isn't it? So that crack might be extensive enough. Now, furthermore, if it is getting expanded continuously, if it is getting pulled apart continuously, what will happen to the central portion? Where will the central portion go if it is being pulled apart? Do you think the central portion will be kept as it is, and in the surrounding areas there will be a depth or a depression which will give you a peak or right up till the core of the planet Earth? No. The central portion, because it is no longer having that support from the sides, it will start falling down. You would have played with blocks in your very pre-teen years, and in fact in your kindergarten years when you were tiny tots, you would have played with multiple blocks. So what happens in those blocks, you would have observed that generally when you remove the blocks which are supporting the central one simply tends to sink. So after some time it will have an impact, or it will have a portion landform like this. Okay. Now this is created why? This has been formed why? And because of the tensional force. Now, because of that tensional force from both sides, the central portion has sunk down. This central portion has sunk down because of tension. Tension, we have also seen, rift also refers to the kind of tension, right? And here you have a valley like structure created. So these are also what are known as rift valleys. Okay. Or they are also referred to as graben fault. So graben fault is a combination of two normal faults. Combination of two normal faults. Okay. Example, Narmada Rift Valley. Another example, Damodar Rift Valley. Have you heard about the river named Damodar? It is a tributary of which river? River Damodar is a tributary of which river? Are we aware of that? Or is it not a tributary? Hooghly, Ganga, Ganga, Tapti, Ganga. Okay. Yamuna, Mahanadi, Ganga. Only one person has given the correct answer. Two now. Two have given the correct answer. Hmm. See, these things, you should not rely on these things that finally somebody will teach us about River Damodar, then we will get to know. This is something that you should gain as your common sense and your general awareness also. Till now, I have four people rather, who have given the correct answer. So I'll take your names also. So I have Kambhapati, Yogi, Prasanna, and Jia. Not Prasanna. Sarthak and Jia. You have given the correct answer. Trivendra, you have also given. It is River Hooghly. Damodar is a tributary of River Hooghly. Okay. All those who have said Ganga, it is not a tributary of River Ganga. In fact, Hooghly is a distributary of River Ganga, and Damodar joins that. So that also moves through a rift valley structure. And that rift valley structure, particularly enriched in coal deposits, etc. Okay. Now to the sides of this graben, generally you will come across an elevated portion. Across the sides of the rift valley, generally you will come across the elevated areas. Okay. And this oftentimes they are eroded to varying degrees. So generally on the sides of plateaus, you will find these rift valleys, and many of the times they will get eroded to form small hill like structures. So that also is observed. Now here, graben is a combination of two normal faults. Then, combination of two reverse faults, they create what is referred to as a horst. So, horst is combination of two reverse faults. So, what happens in the case of a horst? So, here, for example, let's suppose you have a larger rock system, and let's suppose it is being compressed from both sides. Now, as it is being compressed from both sides, it will develop some cracks, isn't it? It will develop some cracks here, here. It might develop some crack here also. Furthermore, as the rate of compression continues, this crack might get more extensive. This crack might get more extensive, isn't it? And furthermore, if the rate of compression continues, what will happen? The central portion will simply be thrown upwards, right? As the rate of compression will continue to increase, the central portion will be thrown upwards. So what you have will be a structure somewhat like this, where the central portion has been upthrown. So this is what is also referred to as a horst. Okay, this is what is also referred to as a horst. And basically, over a period of time in this horst, again, the same thing will happen where it will erode it, and you will have few of the mountains that will be apparent. They are known as block mountains. They are not the fold mountains. They are known as block mountains, right? So this leads to formation of block mountains. Example, you will observe Vindhyas, right? Then you will also observe the region around Vosges in Europe, even the region of, for example, Drakensberg in the region of South Africa. There also in certain areas you will find the presence of these horsts. So that is the case of horst, where you have a combination of compressional forces from both ends as they are acting. The central portion simply gets upthrown. The central portion simply gets upthrown. So this is what actually ends up getting formed at the end of it all, be it graben or a horst, where let's suppose you have a graben. So here, as I told you, around the graben, the surrounding areas have a kind of an elevation and they are eroded, forming that hill-like characteristic. So this you can think about an analogy of this is what the Narmada Rift Valley is. Rift Valley is. This will be your Satpura. This will be your Vindhyas. That is why if you take a proper look at the map of the country, and if you take a look at the portion of the central part of India, you will come across the scenario that Vindhyas and Satpuras, they are almost parallel to each other. And in between them, you have the Rift Valley structure through which river Narmada flows. So that is the case of the faulting and why the process of faulting and why the process of folding does take place or does happen. Okay. Dikshit, between the reverse fault and the normal fault. Normal fault is because of tension. So normal fault, as you are pulling things away from each other, one portion simply, let's suppose these are the rocks, intertwined rocks. Now one portion, as it is getting pulled apart, a crack develops. And then as you pull it further apart, the movement will happen across these rocks. As you're pulling them apart, the movement will happen across these rocks. Because the rate of movement will be very, very slow. 1 millimeter every year, or maybe 2 millimeter every 5 years. That can be the rate of movement. So there will be one portion which will slowly and steadily sink underneath the other. That is a normal fault. Example of it, Western Ghats. Example of it, Drakensberg in South Africa. Then reverse fault. Let's suppose you have a rock structure, you are compressing it. Due to compression, a crack has developed. Everybody please notice this. A crack has developed and you are pushing it continuously. So what will be the movement? One portion will be thrown upwards almost. So that is a reverse fault. A similar process has also ended up creating the Tibetan highlands, the Tibetan plateau, where the compression which was happening across the Eurasian landmass particularly picked up or elevated the land area to such a elevation, to such a height, that you have the highest plateau across the entirety of the world, right? So there have been multiple different reverse faults created beyond the Himalayas where that ascension of the land happened, and hence Tibetan plateaus are so very high. Okay. Yes, Kambapati, both tensional and compressional force can create faults. For tension force, energy required at middle of the plate, where that energy will get. Is this also a result of divergent plate? Absolutely not. For example, let's suppose you have a landmass like this. Let's suppose. Now there is internal heat present. Internal heat is getting provided here, let's suppose. Now that heat means, let's suppose, that the material here gets inflated, swollen up, right? So this will exert a push on both the sides automatically within the plate itself. So if you are talking about a larger rock portion from one area, if the rock is not, or this side, if you consider a larger rock portion, let's suppose here, the rock is not allowed to move this side. It is not allowed to move this side, let's suppose. And there is a movement here. So in this area, can we say that there is a compression which is acting? But is it happening because of plate movement? No, it is happening because of endogenic force. So that is where it can lead to development of a fault in this region. Okay. Horst can be as big as a mountain, my dear friend. Not only big as a building, but as big as a mountain. Does rivers are also formed in this graben nature? No. But graben, they are generally regions of slight depression. So the river, they tend to, or they prefer to flow from that area. Okay. Last slide. Okay. Jyoti, do earthquake occur due to fault plane sliding down? Yes, absolutely. And when sliding up, what happened to the underneath gap? See, understand, that is, so this misconception or this confusion that few of you are having, I think few of you will also have this confusion that what if you are talking about that in graben the central portion sinks down, what happens to material underneath? A portion gets uplifted, what happens to the, is there an air pressure or a gap created? No. So this confusion is created in your mind because you are thinking about this as a fast process, that suddenly the portion is sinking down or suddenly the portion is getting lifted up. So what will happen underneath it? Try to imagine it as a very slow process, very, very slow process, which will take millions of years in order to get created. In order to get formed, it will take millions of years. Then, if you apply your logic, so even if a material is falling down or is being pushed up, you will have other materials from the surrounding which will fill this portion, isn't it? So that is why you don't have that problem that a gap will be getting created in certain portion. The layer of asthenosphere comes closer, right? So to the region of moho discontinuity, in certain region asthenosphere gets slightly pushed from the region of moho discontinuity. So that slight variation happens, but because it is such a slow process, that no gap is left behind. Okay. This is the reason because the Western Ghats is slightly tilted. In fact, that is the reason why the Western Ghats has got a very steep western edge. Okay, you had a substantial portion of land area to the west of it, which has sunk down. That is something that you find in underneath the Arabian Sea, closer to the coastline. That is why that is the region which has got deeper coastline very close to the coast. Okay, and then Yogi, in south part of Western Ghats, the elevation is more than. We'll come to Indian geography. We'll talk about it. We'll talk about the Deccan Plateau, Western Ghats all together. Don't worry. And Shyam, I think you also had the same question, that how the middle portion is slightly sink down. Is there any vacuum or a gap at bottom? So I hope you understand that it is not the case of having a gap or creation of a gap, because the movement is so slow at a particular depth, that is, as you reach the level of the mantle, the entire lithosphere consists of crust plus upper solid mantle. So that entire portion is sinking. There will be slight adjustment that the rocks will make over that small portion. This is not happening across the planet. This is happening in a small portion. So in that portion, there will be now. Shreyash, you had problem in this particular slide. So here, when we talk about the simultaneous existence of host or graben, you have to understand that in many of the cases, due to that particular compression or tension, for example, let's say a graben is in existence. Graben is a rift valley, right? Where you have a tensional force. Now, in that case, we have seen in the case of a graben that this portion has sunk down, but this elevated portion is left behind. So, in comparison to this elevation, points A and points B will be considered to be elevated in structure, isn't it? Now, this point A and point B can also get eroded. This point A and point B can also experience compression, by the way. This point A and point B can experience their own different set of forces. So, here also, this is also referred to as an adjoining host, right? Because of creation of fault plane, one portion is left above, the other portion is left down. So as the portion which has been left above or has been pushed above, now that portion would have at one point of time been flat and featureless depending upon the landmass, but over a period of time it has been eroded by the wind, rain action, etc. That has left behind these mountain like formations. These hilly mountain like formations has been left behind, and so is the case other side also. So when we talk about the Vindhya and the Narmada Rift Valley system, now understand, look at their location. They are almost in the northern areas of the peninsula part of the country, the peninsula plateau of the country. Now, as the Indian plate was experiencing that convergence with the Eurasian plate, there were various different compressional pulls and push which was experienced. Right. While the sedimentary portion of the Indian plate, the sedimentary plain portion of the Indian plate got folded, led to the formation of the Himalayas along with the Tethyan sea floor. But the plateau portion, consisting of hard igneous rocks, they could not get folded with the same rate. So that is where they developed multiple different host and graben simultaneously. And that is where you have the Narmada Rift system. Close to it, you have the Vindhyan mountains, which are a host which has been eroded. So that is why whenever you get an opportunity to drive through the region of the Vindhyas, be it in Madhya Pradesh, be it even in some parts of Chhattisgarh or in Maharashtra, you will observe this kind of an elevated pattern where if you visit, let's suppose, if you have visited the region of the Himalayas, you will find a very different kind of a pattern of the mountains. Whereas in Vindhyas, you will find faces which are, or portions which are almost vertical, right? Portions which are almost vertical and which will give you an idea about the various different layers also. I don't know how many of you have basically driven down that region or moved through that region, but if you ever get an opportunity to move through the region of the Vindhyas, you should do that. You will observe that, for example, what I'm trying to convey here, you will observe a mountain formation or a mountain having a shape somewhat like this in many of the cases. Whereas in the Himalayas, you will have a mountain like this, right? And here in Vindhyas, you'll find the various different layers. Those of you living in that area will always, or in the region of Maharashtra or in Madhya Pradesh, you would have seen this in your day-to-day lives, right? Good. And right, so Dhyan, so the Western Ghats today formed due to normal fault? Yes, my dear friend. Is there possibility of lava coming on the fault? Only in the cases where you have a large fault line created and the aspect of melting point that we have talked about. But in most of the cases, 99% of the cases, it is not so. And are the Central Highlands a result of the host fault? No, Central Highlands are a result of that upliftment which has happened. Again, yes, reverse fault is a reason for that, but not particularly host. And Ritika, please discuss, a river is flowing and on the bank of river there is raised land. What will it be called? It will be called as natural levees. It will not be called as a host or anything like that. It will be called natural levees, something that we'll cover in the next one. Okay. In this picture, Narmada Valley sank down or Vindhya has been uplifted. It has been a, a combination of both of them. A combination of both of them is something that you find here, right? It is the Narmada Rift Valley which has basically been due to the tensional forces has sunk down, but then also simultaneously the other portions have been uplifted close to it. Not so much as the Satpura. Satpuras have not been uplifted. Satpuras are just the side of the graben that you can consider elevated portion on the side of the graben, but the Vindhyas, they have been elevated. Okay. In the case of graben fold, can folds might be possible other side? It depends on the type of the rock surface. It depends on the type. Generally, near the graben or rift valley structure, you will find that the rock structures are so very. You have so very hard rocks that it doesn't break very easily. So, or it doesn't get folded very easily. It breaks easily. So, rather than near the rift valleys, you will mostly find the presence of host faults or block mountains rather than fold mountains. Okay. Horst sometimes is also created due to graben, but Horst many of the times is created due to compression also. I think I have answered all the questions. Pratik, Vindhyan region is a result of normal or reverse faulting? Reverse faulting. Um, okay. Is the Grand Canyon of Colorado is Horst graben landform? No. The Colorado Plateau in United States is experiencing the convection current from the bottom. That is why the Colorado region of Colorado Plateau has experienced an upliftment. Right? It is the land. Remember, I told you the analogy that when heat is provided from below, what happens if you are cooking a chapati, it tends to inflate, right? So, similarly, like that, when you basically take a look at the Colorado Plateau, the region of Colorado Plateau is experiencing that heat from underneath, due to which it is inflating as of now, developing the cracks. So, over a period of the past few hundreds of thousands of years, as this has elevated itself, the portion of the rivers, etc., where they are flowing, they have maintained their original position. That is why you observe so deep canyons, the Grand Canyon structure being one of them. Okay. After this, we'll take a break. Don't worry. Shubham, I hope that is understood. Okay. Now, Ritika, there are all this concept clear. Good. But when we see all together, this all get mixed up. Then don't see them together. See them separately. See them, revise them, you will get better at it. Concept, if it is clear, see, if you are having that expectation that what I have read now and I will take the same information, or with the same mindset I will go to the exam hall and I'll write good answers, that is absolutely impractical, impossible. If you don't revise all of this separately, not together, separately, each of them separately, you'll forget it maybe by later next month, or by January if someone asks you Horst and the case of graben, suddenly you'll be wondering whether it is a mineral, whether it is a type of a climate that you are talking about. You will be confused by that. Unless and until you carry out revision, there is no way that you will be able to retain all this. Okay. So now we take a break, and after this, we continue further. So we take a break for 15 minutes. Okay. If students seen the first time of map, how to understand the map in a better way? Okay, we'll talk about it. Santosh, I understand the predicament. We'll talk about it in detail. Let's take a break. A confirmation about the audio, please, guys. If the audio is clear. Thank you. Chandrajyoti, it refers to the ridges zone, ideally. But then I saw the mail also that you sent me yesterday about it. So I'll take a look into that. If possible, send me a screenshot of that and I will let you know. Okay? I hope that works. So now, tomorrow, by the way, tomorrow again we are meeting. Tomorrow again we have a class in the morning. Okay? Right? Now, we move ahead and with the portion of landforms, erosional and depositional landforms. Escarpment, basically, Anurag, is that feature which is left behind when in a normal fault, one portion of it simply undergoes, some subsides. The other portion which is left behind, that is referred to as the escarpment. Yes, tomorrow we will have the same timing for the session also. Yes. Yes, Nikhil, you can. So here, we talk about the portion of landforms and basically the landforms which are created by the external forces of the nature. So till now, whatever portion that we have studied, be it the plate tectonics, be it the aspect of the movement of the plates with respect to each other, earthquakes, volcanoes, faults, folds, all the things that we have studied till now, in all the cases we have seen that they have been created or they are acting because of some or the other property in the interior of the planet. Because of heat in the interior, be it the residual heat or the heat in the asthenosphere due to radioactive materials, more or less, it is the heat in the interior which has resulted in those kind of events. But then, on the surface also, you have various different forces which act, which keep on acting, be it the rainwater, be it the river water, be it even the case of the glacial movement. So such forces, they keep on acting and they are also referred to as the exogenic forces or the forces which are acting from the exterior. So they are also referred to as exogenic forces acting from exterior. Okay. Now, these exogenic forces, they are also referred to as levelers. Because regardless of whatever might be the feature of the land, be it a plateau, be it a mountain, be it a plain, eventually everything will be reduced to the plain area, right? Regardless of whatever might be the feature of the land, like this, right? Everything will be regarded or relegated to a kind of a plain region. So that is why exogenic forces, they are also referred to as levelers. So in this particular module, we are going to study the landforms which are created by the exogenic forces. We are going to come across events such as weathering. We are going to familiarize ourselves with what do we understand by weathering. We are going to try to understand the different types of weathering. Then we are going to look into the aspect of mass movement, what is referred to as mass movement, what is a landslide. Then in Indian context about the landslides, we are going to study it in the portion of Indian geography, but we shall introduce ourselves to the terminology of those particular mass movement. Then we are going to study the various different phases of river movement, the youthful phase, the mature phase, and the old age of the river movement, and what actually are the types of landforms created in the process: erosional landforms, depositional landforms. So all these are something that we are going to cover. So relevance for the examination in prelims. In prelims, you basically will observe this basics of weathering and erosion, and then also we will be covering, or what is also relevant is types of landforms erosional and depositional. Depositional. Their basic features is also something that can be asked. And in the mains examination, earlier this area wouldn't be very relevant. This is one of the favorite portions of UPSC when it comes to optional. So whenever I ask anybody who is studying for optional paper, they will have to spend a lot of time into this, considerable amount of time into this. But for GS, UPSC had been largely ignoring this for a long period of time. UPSC has started concentrating upon this again when this year it asked a direct question from this particular module. So here you will have questions. You can expect questions about basics of weathering again. Okay. And then also stages of river movement. Then also you have types of landforms and their basic properties. Features of these landforms. So for each module, by the way, guys, for each and every module that we have covered and that we shall be covering, in on the first slide of the module, I have ensured I have written which is the portion relevant for prelims, and I will also write which is the portion relevant for your mains examination. What I expect out of you is that when you carry forward that process of revision twice or thrice, you shape your narrative along with these particular pointers, along these pointers to sharpen your understanding also. Okay. So now, when we talk about the movement, Earth's movement, now Earth's movement and its impact on the surface basically can be divided based upon where the forces are acting from. You have the endogenic forces and the exogenic forces. Endogenic forces, forces acting from the interior. Acting from the interior. Right? And then you have the exogenic forces acting from the exterior. Till now, we have covered this endogenic process. We have covered that portion completely. Now we have to cover exogenic forces. Now, within the endogenic forces also, we have seen that there are forces which act all of a sudden forces. For example, earthquakes and volcanoes, they happen immediately. It is not the case that a volcanic eruption is happening for the past 100 million years, material is continuously moving out. No, when the volcano has to erupt, it will erupt all of a sudden. Similarly, when we talk about earthquakes, it is not as if in any part of the planet you experience that, okay, there the earthquake has been happening for the past 100 years, continuously earthquake is happening. No, it will happen all of a sudden. So those are sudden forces that we have studied. And we studied the slow forces, slow acting forces, which are the diastrophic. They are also the slow acting forces, in the sense that they act over a very large period of time. So, for example, the folding of the mountain, the creation of a fault, etc., that is a slow process. It takes a very large, considerable period of time. So you have orogenic and epirogenic. So we have seen that you have forces whereby the land is pushed up or the land simply subsides. Similarly, you have the folding, faulting. So they come into the category of diastrophic forces. So when we talk about, very briefly, I will again in a couple of slides I will tell you what diastrophism means, and we have studied all of this, and then we will switch over to the exogenic forces. So when we talk about diastrophism, it is the process of deformation of the and that leads to changes in the Earth's surface. Now, many of the basic structures, such as plateaus, mountains, folds, etc., in the crust, they get created due to diastrophism. Diastrophism is a slow acting endogenic force. So endogenic force of two types: sudden forces, earthquake and volcano; slow acting forces, all the other things that we have seen happening, where compression, let's suppose compression elevates this land, then tension basically does that. Then further, as they move against each other, they might develop a fault or a crack thereby, or a joint thereby. So all that belong to diastrophism. Now diastrophism again subcategorized into two parts: aperogenic and orogenic. Orogenic, whenever you hear anything about orogenic, it is to deal with the mountains, right? Orogenic, orographic, whenever you come across any of these terminologies, it has got to do with the mountain systems. So orogenic forces, the mountain building forces. Now the mountains can be created by folding. We have seen the different types of folds, and also by the process of faulting, where you can observe the existence and creation of block mountains. Example of block mountains we have seen: Vindhyas. Remember these examples. These examples, you can write it in your answer paper, authenticate your answer furthermore, get more marks. And also these examples help you in gathering a larger picture of what is happening around the country also. Now, aperogenic. Aperogenic are what? So these are also known as the continent building forces. These are the vertical forces. So due to heat, etc., we have seen that some portions of the land, they are pushed up, they slightly get inflated, or they rise up. I have given you the example of the Colorado Plateau right now, and other areas also, they have risen up, right? Many areas have sunk down over the past history of the planet. Many areas have sunk down, many areas have risen up. So that comes under the category of, or the categorization of, aperogenic. Both of them are a part of diastrophism, slow acting forces. So this is something that we have studied till now, right? Under plate tectonics, etc., volcanoes, earthquakes, folding, faulting, we have covered this. What we have not covered till now are the exogenic forces. Exogenic forces are the forces acting from the outside on the surface. Now these exogenic forces, they basically are also known as levelers, right? They are known as levelers. Endogenic forces, many of the times you will hear the terminology from geophysicists, geographers, etc. Many of the times they will tell you that endogenic forces, they will refer to it as tectonic forces, right? Simply tectonic forces, because of the plate tectonics, etc., which is involved. Exogenic forces are oftentimes referred to as levelers. Now why levelers? Leveler means what? Something which levels the land. Why is that? So basically, if you try to analyze all the various events which happen on the surface, that you observe on the surface, or all the events that you have observed, endogenic forces, obviously, not many of us would have observed that or understood that this is an endogenic force. But whatever you see, for example, a landslide which happens, landslide does what? It basically brings materials, rock portions, etc., from the side of a mountain right to the bottom, isn't it? For example, let's suppose wind is moving with a very great and swift velocity. It will carry away the materials. But from where? From a certain elevation, right? So eventually, I'm not going to go into the cycle of erosion and the cycle of degradation. Generally, there is a kind of a particular process and principle involved there also. Various geographers such as King, such as Penck, Davies, all of them, they have provided their various theories to help explain why erosion happens in an area, till what level an erosion will happen, etc., etc. But we won't go into that. Just to give you a brief analysis, suppose here you have a landmass which is like this. Suppose you have a small hill, you have a plateau, you have a depression, a depressed area. Now, eventually, what you will see happening, if this is, let's suppose I regard this as a sea level. Let's suppose this is your sea level. Not that sea is present here, but just to give you an idea about height. Because when we measure height, we always measure it that Mount Everest is 8848 meters above sea level, right? Mariana Trench is almost 10.5 kilometers deep below the sea level, right? So sea level is the normal reference point. So let's suppose this is the sea level. Now, over a period of time, you will find that landslides, etc., will bring materials into the depression, will erode this, will erode this, and eventually, what you will end up attaining is a kind of a level piece of land. After many hundreds and thousands and millions of years, you'll find this as a level piece of land. Everything would be eroded, everything would be taken away. For example, I understand, I absolutely understand that right now it would be incorrigible, incomprehensible for many of you to even imagine a situation where a mountain can disappear. But look at the Aravallis. The Aravallis that we have, they are an example in front of us. Aravallis are amongst the oldest fold mountains of the entirety of the world, amongst the oldest, right? Aravallis were created billions of years back. Now, these Aravallis, at one point of time, by the way, they were so very tall that you had the region of the Aravallis beyond a height, they were covered with snow and ice. It is said that mighty glaciers, what you observe in the Himalayas right now, such mighty glaciers would have moved through the Aravallis and large rivers would have originated from the Aravallis. But the folding process stopped. That means the increase in height stopped. And then the external forces, external pressures of wind, river movement, etc., that took over. And what has happened to the Aravallis now? If you observe them, it is not even referred to as a mountain anymore. It is not, many of the times, it is referred to as a hill. But what Aravallis are nothing but remnants of an ancient, magnificent mountain. Right? For example, in the region around Delhi, if you go from the region, from the western part and you enter Delhi, you will find that you have the ridge, which was once a part of the mighty Aravallis, that has been reduced to a ridge. And that ridge continues all the way till Haridwar, what is referred to as the Delhi Aravalli or the Delhi Haridwar ridge axis. So imagine at one point of time, the Aravallis would be stretching all the way from the region around Gujarat, all the way till the region around Haridwar. But do you find that now? No. In many of these portions, they are absolutely absent. In the remaining portions, their height has reduced quite significantly. You can cover this Aravalli mountain in one day. Aravalli hill, you can scale it up in one day. Right? In many of the areas, it has already been eroded by the rivers, etc. And in the remaining areas, we humans, we are carrying it out. We are carrying out the mining and the digging of the Aravallis, which eventually will erode everything. So what I'm trying to convey here is basically, regardless of whatever features the endogenic forces create, a mountain, a plateau, a depression, a hill, the exogenic forces fill it all out or level it all out. That is why they are known as levelers. For example, as we will study about this in the portion of Indian geography also. Now, the northern plain of India, the Indo-Gangetic plain, is very, very fertile, supports a population worth many crores, many millions of people live there, right? If you ask anybody, what is that region made up of? Anybody out there, everybody will tell you very fertile soil. This is a region of a fertile soil. But if you ask people, what was this region before that fertile soil came here? What did the region look like? That region was a deep depression. That region was a depression which was created during the time of the formation of the Himalayas. Now imagine, so when you are staring at the reality around few million, tens of million years back, there was no northern plains. There was no fertile sedimentary plains in that area. It was a depression. But what has happened now? It is a plain area, almost closer to the sea level, right? So a depression has been leveled to the sea level almost. A mountain has been leveled to the sea level almost. That is why exogenic forces, they are known as levelers. I hope that is a point taken and understood. Now, here, when we talk about these exogenic forces, they act in various different manner. So many of the times what happens, the existing rock structure, wherever they are present, there itself, by events of heating, cooling, rainwater, plant animal action, chemical action, etc., they end up breaking down. For example, in the case of the older mountains, you will observe that slowly and steadily the rocks, they start dissociating, they break down, and eventually the mountain size reduces. So when the rock structures, etc., they break down in the region itself where they are found, in that location itself, that is known as weathering. Sometimes you have events such as landslides, right, debris flow, etc., where suddenly, all of a sudden, large amount of materials, they come down the slope of a mountain. Sometimes you also have very large pieces of rocks which start falling immediately down the slope of the mountain. I'm sure many of you would have seen that horrific video doing rounds on social media where you had rocks falling down from the mountain and in the region around Nagaland, and it basically crushed the various different vehicles that were on the road nearby. So what is that? That is when large amount of materials suddenly tend to flow. So that is mass movement. And then you have the process which is known as gradation. Gradation. Gradation is what? Again, a process of leveling. A process of leveling, where from an uprised portion, if a river is moving, it will erode that area, it will erode that region, and it will deposit sediment somewhere else. So that process of eroding something, transporting that material, and depositing it somewhere else, that is your gradation. So this can be carried out by the running water of a river, by the groundwater, by one of the most massive forces that the Earth's surface experiences in the form of glacial movement, by the action of the sea waves, and also by wind action. Right. So here we are going to concentrate on all three of them, all these three process of, or all these three exogenic processes, and we are going to try to understand that, but we are going to understand all the landforms created, erosional or depositional, most of them which are relevant for your GS, most of them which are created by the process of these agents of nature. So starting first of all with the process of weathering. So when we say weathering, what is weathering? Right. So weathering is something that you use in English language also, right? For example, the hot climate weathered me down, or all the players were weathered down by the excess humidity and high temperature. So when we talk about weathering, weathering for a rock system, or in terms of geomorphology, it refers to that aspect where an existing rock in its own location breaks down or disintegrates into multiple smaller parts due to the events happening outside, by rainwater, by temperature condition, etc. So due to external forces, they break down into smaller components. So here, let's suppose you consider a larger rock system. So breaking down of the rocks into smaller pieces or fragments naturally in its place of, or in its own location. That is what is referred to as weathering. Now, it can be initiated, that breaking down process can be initiated because of the events of the physical forces acting, the chemical reactions which the rocks undergo, or by the biological events as well. So, accordingly, the weathering is divided into physical, chemical, or biological weathering. For example, suppose when we talk about the physical weathering, what is physical weathering? So, here, let's suppose you have a large rock structure. Let's suppose. Now, this large rock structure will, let's suppose this is the rock structure. Now, during the summer time, it will tend to expand. Every material tends to expand when heated. During the winter time, it will contract ever so slightly. Again, during the summers, it will expand. So, this process will continue, won't it? Now, as this process continues, expansion, contraction, expansion, further contraction, the structure will be weakened. It might develop a crack altogether. Let's suppose it develops a crack here due to the expansion contraction. Now, if rainfall happens, now in the event or the occurrence of the rainfall, that rainwater will also penetrate. Let's suppose the rainwater has penetrated this, right? Now, it might happen that this rainwater is left there only. Now, during night time when the temperature plummets, or in regions where in winter the temperature reduces quite significantly, this water can get converted into ice. Once water gets converted into ice, what will happen? Water, I hope we are able to understand, or I hope we have this understanding that when water gets converted into ice, it is an expansion. Ice is an expanded form of water. So as this stored water will get converted into ice, it will tend to expand. Now, when it tends to expand, what will happen to the rocks or the crack there? So the crack will further deepen, isn't it? Eventually, it might be complete and the rock might break off. Okay, but this breaking has happened. Why? It is not a human induced event. This breaking has happened because of other external factors such as heating, cooling, higher temperature, lower temperature, rainwater, freezing, melting, etc. That has led to the breakage of the rocks. So that is physical weathering. So physical weathering is the breakage of the rocks caused due to the heating, cooling, properties of rainwater, freezing, melting, when they will weaken the rock structure to such a way that the rock disintegrates or breaks. That is your physical weathering. Then you have chemical weathering. Now, chemical weathering, where basically in most of the cases, what you observe is that when we have rainwater, rainwater will contain certain chemicals many of the times. It will have its own chemical property. But at the same time, let's suppose you have a rock which consists of chemicals which are soluble in water. Let's suppose in the same rock structure, let's suppose I have a particular region here. This is a region which is particularly rich in calcium. Calcium. Now, calcium, it can be calcium carbonate, sulfate, anything. Now, calcium is again soluble in water. Water is able to dissolve calcium very easily. Now, if this region experiences rainfall, if this region experiences rainfall, then what happens? This water will start dissolving calcium slowly, steadily. It will keep on dissolving over a period of time. Let's say after many hundreds, tens of years, this would have been dissolved. After again hundreds of years, the entire portion has been dissolved. So over a period of time, when the entire portion of the calcium is dissolved, this rock will break off. But this breaking off of the rock has happened. Why? Because of the chemical reaction. Chemical reaction between whom? Between the materials which are present in the rocks and the outside environment. Maybe river, maybe rainwater, anything. So that is chemical weathering. And then you have biological weathering, where life on planet Earth, for example, the events or the, let's suppose, the plant growth or the rodents, right? Now, rodents and reptiles, they've also dig burrows in the rocks. They also have burrows in the rocks. So let's suppose there is a kind of a crack which has developed. There is a kind of a crack which has developed on this rock. And on this crack, you have a plant which is growing. I'm sure most of you would have seen this. In the rock, when it is barren, there is a small crack. There are plants which grow. In case you have not seen this, if you have seen any of the older government houses or the government buildings, for example, right? Now, in the older government buildings where no maintenance, etc., is carried out, you will observe that from some external part, some plants will start growing. If you don't repair it immediately, those plants, their roots will start extending within the walls. They will expand the cracks within the walls. Eventually, the wall might break off. Something very similar might happen here also. You can have small plants which grow, and these plants basically will have their roots which will extend. And basically, after some time, maybe another plant will grow here. Because in the rocks, you have various minerals which can be extracted by these plants. Now, noticing that the plants are here, you might have a rodent which comes here, digs a burrow furthermore. After this, as it continues, the crack will get deepened and deepened and deepened, and eventually it can break off. So, that is how the rocks can get broken into smaller components, smaller subparts. And that breaking into smaller parts, if it is happening purely by heating, cooling of the rock, freezing of water, expansion of the cracks, melting of water, etc., that is your physical weathering, where these physical forces, they alter the property of the rocks, or the change the nature in such a way that the rocks disintegrate. That is your physical weathering. During heating it will expand, during cooling it will contract, again heating it will expand, again cooling it will contract. So over a period of hundreds and thousands and sometimes even millions of years, that will be broken into many smaller portions. If, let's suppose, the rocks get broken into smaller components by the dissolution of materials, the materials which get dissolved. Now, for example, you have the rainwater, river water. If they start dissolving materials which are present in the rock can get broken into smaller components. That is chemical weathering. But if the weathering is happening due to the biological processes, biological weathering. Out there in the nature, it is not as if this rock will break only by physical weathering, that rock will break only by chemical weathering, and that rock will break only by biological weathering. No. Out there in nature, you'll find that there is a combination of all of these processes happening at the same time, and eventually the rock will break. In the sense, generally, you will find that heating and cooling leads to the development of large cracks in the rocks. Through those cracks, rainwater might enter. If it is a cold region, then the rainwater might freeze. And when it freezes, it will expand. As it expands, the cracks will also expand. More rainwater will enter, right? And then in that region, plants will grow, animals will come. The rainwater, as it penetrates furthermore, it will start dissolving certain materials within the rocks. So simultaneously, many of these processes act in conjunction, and that leads to the breakage of the rocks in the original region itself. That is what is regarded as the process of weathering. Okay. Now, I hope that is understood. Now, after this, when we talk about mass wasting or mass movement, Akhilesh, how ice is expansion of water. Rajan, how ice is expand form of water as water is in liquid state and ice is in solid state, as solid state is has so closed particles when it is compressed. No. This should have been covered in your school science classes, I think. This is where you read about the science classes, where elementary chemistry and physics that you read. Okay, how many of us are not aware about the property of ice and water? Water indicates ice and water. They represent an anomaly that in other liquids, when you will solidify those liquids, it is a compressed form. In the case of water, when you freeze it up, it is an expanded form. I hope you should be aware of that. That is because when we talk about ice, ice has a crystal structure, crystalline structure, right? So the molecules, they form individual crystals. So the molecules, if you have to imagine it, think about it, they will form crystals like this, a crystal arrangement like this. Whereas such crystalline arrangement is not found in liquid water. So when they arrange themselves in that crystal lattice as it is referred to, you have a lot of gaps in between. That is why always you would have found that ice is lighter than ice floats on water. You would have seen that, isn't it? That ice tends to float on water. Why? It is because it is lighter. Why? Because it is an expanded form of water. Okay. So I don't want to go into basic physics, guys, because if we go to the basic physics, then why the ice of freezer and natural ice is different? Because of the property of the water which is getting frozen up. Chemical and biological weathering is possible in igneous rock? Absolutely, yes. Why not? Absolutely, yes. The Raisina Hills, Anurag, are they part of the Aravalis? Yes. The entire hill system was supposed to be a part of the Aravali systems itself. And as we move ahead later, if time permits, we'll also talk about that how the destruction of Aravalis, what we are doing right now. For example, those of you belonging from Rajasthan, and even those of you not belonging from Rajasthan but having a very keen eye in, let's suppose, the political development, politics of that region. Now, a very good article was published in the print recently about the rise of sand mafias in Rajasthan, where they have become so very powerful, they are able to sway elections in their own region, those sand mafias. Now, where do they get all that money from? By digging up the Aravalis, right? By carrying away the Aravali region. Now, that is used for construction purposes eventually. And in that process, what we are doing, we are extending the Thar Desert further into the region of Delhi. Aravalis had prevented that spread of Thar Desert into the region of Delhi, Uttar Pradesh, Madhya Pradesh, etc., Haryana even. That is why, in the recent past, if you would have observed, there are greater number of sandstorms, something that you see only in movies and in the African region. Those sandstorms are becoming very, very prominent in the region around Delhi, NCR, in the region around Haryana, etc. Why? Because we have removed the Aravalis from that region. So, by that process, these sand mafias and the politicians who are giving them all the good support and shelter from all the political parties. It is not as if only one person is responsible for this, from all the political parties. Invariably, they are leading to the destruction of the entire ecosystem of northern India. But that is happening in the name of money. When the greed is so very high, you don't care for what happens 10 years down the line, what happens 50 years down the line. You care that if I have money, I will shift somewhere else. So that is something the that is very apparent in case of erosion of Aravalis. Okay, that is my plan B. What, becoming a sand mafia? Is that your plan B? Okay, fair enough. Right. So I won't comment on this at all because I might be thought to be a kind of a partner in crime. So I will leave this topic here itself and we'll move to the portion of mass wasting. So, mass wasting. What do we understand by mass wasting? So, this is a terminology which is used to refer to mass movement. When you have movement of a bulk of materials at the same time, right? So that is what mass movement refers to. This is also what is referred to as mass movements. It's okay, Rajan. I hope that you have understood it now. So this is your mass movement, where you have a sudden and a large scale movement of materials. Now, why will the materials move? If you think about it, why will the materials move? If let's suppose I have a region like this, I have a lot of loose soil, etc., which is present here. Will it suddenly start moving? No. If it is absolutely a plain region, it will not move. But if I have a region, let's suppose, which is like this, and here I have lot of materials, loose soil, etc., will that move? It can. If there is excess rainfall, if there is a river movement, it obviously can. Why? Because now you have the component of gravity acting. So materials or movement of anything, soil, rock particles, etc., everything will move under the influence of gravity. Everything will move under the influence of gravity. So gravitational influence is very much required in order to ensure the mass movement. And sometimes that gravity, that gravitational force, that is responsible for an accelerated rate of movement, for a slower rate of movement as well. For example, if let's suppose I consider two conditions and I give you two of such conditions. One condition is where I have a mountain structure like this, or a cliff-like structure like this. Here I have loose rocks, let's suppose. Loose rocks which are overhanging. Okay, here also. And then I give you a region which has got a slope characteristic somewhat like this. Here also, let's suppose I have the presence of these loose rocks. Now, the component of gravity in both these cases are slightly different. In the first case, you will observe the rocks to be falling immediately, directly. Even if let's suppose there is not much supply of water, etc., even then it will straight away start falling. Many of the times you will find that you have straight wall-like cliffs, etc., which are there, and you will observe that it straight away starts falling immediately at the base, isn't it? So these are mass movement aided purely by gravity. This category of mass movement, they are referred to as falls. So you have rock fall, you have debris fall, right? Where basically you will observe that along with the rock, sometimes small sand particles or many of the small rock pieces, etc., they also fall because it is a steep slope. It is almost a vertical wall-like formation. So that is also a mass movement. But here, if you consider this, slope is not that acute, slope is not that significant. So there will be movement, but the movement will be very, very slow, isn't it? The movement will be slightly and significantly slower because the component of gravity is not so high. So gravity is an important factor. Then the other important factors are the volume of materials. Now, what do we mean by volume of materials? This refers to the amount of loose materials in terms of the loose soil, loose rock pieces, everything. The amount of loose materials which are ready to move, right? Aided by the gravity, if you have those materials which are ready to move, right? So if greater amount of materials are ready to move, there will be a greater movement. If let's suppose everything is, if you consider the region of the Peninsula Plateau mostly construed and constructed by the igneous and metamorphic rocks. Now, if you have a region which is completely composed only of rocks, and these rocks are very stable in nature, means you don't have any loose material which will fall, right? So there you won't have any mass movement. So availability of loose materials it determines the amount of material which will move in the mass movement. Okay, so volume of material here refers to amount of loose soil and rocks which can move. And then you have the water content, amount of water. So greater the amount of water, which now water here we are talking about which water? We are talking about rainwater. We are talking about seasonal streams, which get generated when you have a lot of rainfall happening in the mountainous areas. Now, if there is a greater water availability, there is greater chances of the material to be flowing, isn't it? Less water availability, less chances of material to be flowing. Greater availability of water means what? Materials will also start moving with a great velocity, isn't it? Because they will have lesser friction with greater water. It will be like a mud which will flow. And lesser availability of water means it won't have that kind of a flow associated. So that is why you will observe majority of the landslides occurring during the rainy season. Because as the water content is increasing, the ability of the materials to move also is facilitated. So here, increased availability increases the movement. Yes, water acts like a lubricant. Yes. Then, steepness of the slope we have already seen. Steeper the slope, greater is the movement aided by the influence of gravity. If you have very steep slope, more materials will move down. Now here, one thing that you have to understand, that what is the role of weathering? Now, many of the times I have seen multiple different types of MCQs being framed from here, and many of the candidates committing mistakes here. So, when we talk about weathering, so what weathering does? It will reduce or it will break these rocks into smaller pieces, isn't it? It will break these rocks into smaller pieces, provide the availability of loose materials, and those loose materials will move, right? So, greater the weathering happened in a region, greater will be the movement. But then we can say that weathering facilitates mass movement. But can we say that mass movement will never happen without weathering? We cannot say that, right? Because you can have materials maybe carried to that region by a river, etc. But mass wasting can happen even without weathering. Okay, so remember that. So, weathering of weathering of rocks. So, weathering facilitates mass movement by providing smaller materials but when we talk about its absolute role, however, it is not an absolute condition required for mass movement or mass wasting. Okay. While this can facilitate the movement, it is not the absolute condition. Mass wasting can happen without weathering also. Slow disintegration is weathering, fast disintegration is mass wasting. No, incorrect. Mass wasting does not mean disintegration. Mass wasting means materials are carried from one region to another. So we'll take a look at few of the types of mass wasting. For example, landslides, creep, solifluction, etc. These are few of the examples. So when we talk about landslides in particular, landslide. So here, amongst the mass wasting also, we have seen that there is a kind of a fall, that rock fall, debris fall, right? When the slope is almost vertical, materials will straight away start falling down. That is fall. You also have the slides and the flows. Slide, you that can come under the category as landslide, mudslide, etc. So slide is when you have substantial amount of water, and that water, it carries out the loose particles, loose materials along with the rock pieces, etc., and they move, right? So you have landslide. So if you observe this image, this is landslide. So observe that in this entire area, whatever would be the materials in that region, those materials have been brought down, those materials have been carried over, isn't it? Now, why have they been carried over? You have the presence of slope, you would have the presence of loose soil which can easily move, and you would have had the presence of excessive amount of water due to maybe rainfall or other such events. Even this year in Himachal, we experienced series of landslides in the month of July, right? So that is what is landslide. So when you talk about a landslide, it is defined as a movement of the mass of rock, debris, or earth down the slope. It can be identified, initiated in slopes already on the verge of movement by rainfall, snow melt, changes in water level, stream erosion, changes in groundwater level, earthquakes, volcanic activities, anything which will disturb the slope in such a way that the loose materials, they will start sliding along with the rocks, loose pieces, etc., loose soil, etc., everything. That is a landslide, right? So earthquake, shaking, and other factors can also induce landslides underwater, that is in the region of the seas and the oceans also sometimes, and these are known as submarine landslides. Many of the times these submarine landslides, they have been known to damage the underwater cables, the underwater cables which have been laid down between different areas to facilitate communication, etc., they get damaged by these landslides. Okay. In India, the probable zones which experience landslides quite frequently are what? You have the Himalayan region and the Western Ghats region. So in India, when we talk about landslide prone areas, you have Western Ghats and Himalayas. But overall, Himalayas experience greater frequency and greater number of landslides as compared to the Western Ghats. When we come to the portion of Indian geography, we'll talk about it, that why Himalayas experience more landslides, why Western Ghats experiences comparatively lesser, and why both of them are different. Now, then you have creep. This is what is creep. Region around Madikeri in Karnataka. Yes, so that also Surya in the entire region, not only from in Madikeri, all the way from Madikeri, all the way till Wayanad in Kerala, and even for that matter, as you enter into the northwestern portion of Tamil Nadu, that entire region is prone to landslides. But that is very much a part of the Madikeri and the Wayanad region, very much part of the Western Ghats itself. Wayanad is one of those areas which has frequently experienced those landslides. Even if you go down to the region around Munnar, there also you will experience a lot of landslides. Right? Now, creep. Now, creep is something that many of us we would have noticed on a day-to-day basis, but then we have not basically understood that this is a mass movement. Many of you, while you would have moved around the country, moved around the regions, wherever you live, you would have come across a situation where if there is a slight slope, very slight slope, I hope I'm able to depict the slope here. If there's a very slight slope, which is not significant, Northeast region is very prone to landslides, Akhilesh, yes. Landslide is a form of a sudden movement, yes. So here, you would have come across these areas with this gentle slope, where you would have observed that all the boundary fences, they are actually bent in the same direction. Even the trees, for that matter, they are bent in one direction. The telephone poles, the electrical pillars, etc., all of them, they indicate a slight bend, not a great bend, but a slight, ever so slight bend, right? And obviously not talking about those telephone pillars, etc., which are completely flattened to the ground, not that kind of an infrastructure, but basically where you have ever so slight a bend which is observed. Now in those cases, it is actually the mass movement which is happening. So this happens when the slope is very gentle, very gentle. Okay. So in this case, when the slope is very gentle, and the availability of water is also not there. So dry regions, dry regions. So materials very slowly, they tend to move down very, very slowly. That is why you will observe all these bendings, right? In your place also, you would have seen that. Many parts of the country, you would have seen that, not necessarily in certain topography, where you observe a gentle slope, you notice that the boundary walls, etc., they have a tilt in the same direction. So that means the ground or the topsoil in that region is ever so slightly moving along the slope. So that is what is known as creep. This is a very slow rate of movement. Rate of movement. And then you have what is referred to as solifluction. I'm just giving you a few examples of mass movement. You have other kinds of mass movement also. You have mud flow, you have mud slide, etc. You have other kinds also, but I'm just giving you the examples of few of them. Gentle means which is very less. Steep means the slope is very significantly inclined. So gentle slope is this, steep slope is this. I hope we are getting that. Okay. Now, we come to solifluction. Now, solifluction is not observed everywhere. Solifluction, the name in itself, if you observe it carefully. So here, basically, the topsoil starts to move like a fluidic substance. Now, where is it experienced? In which region is it experienced? So, it is experienced in the regions around permafrost. Permafrost is derived from the term permanently frozen. So many parts of the planet, they are covered or they lie in the region which is referred to as permafrost. For example, northern portion of Canada. For example, Greenland. For example, northern portions of Europe and Asia. Now, these are the regions which are referred to as permafrost. Even Antarctica means permanently that is frozen. Now, while in Antarctica, interior of Greenland, etc., that remains permanently frozen throughout the year. But when we talk about, let's suppose, the coastal areas across Greenland, some areas across Northern Europe, now in those areas, during the summer months, the top ice that melts, but the bottom layer of the soil still remains frozen, right? So the bottom layer of the soil is frozen. The top portion of the soil has become ice free. And when it has become ice free, all that melt water will add fluidity to the soil, isn't it? The soil will gain some fluidity. And then, because the bottom soil is still frozen, the topsoil simply decouples or becomes disjointed from the bottom soil, and the topsoil starts to flow. So observe this kind of a flow pattern. I hope you are able to observe this. This is a kind of a fluidic flow pattern that the soil has developed. So this is observed in regions of permafrost, and that kind of movement is solifluction, where the soil develops that fluidic motion. So observed in areas of permafrost. Okay. Now during summer ice melts, lower soil is still frozen. As a result of that, what will happen? Topsoil becomes disjointed, connected, and develops a fluidic motion in the presence of meltwater and other forms of precipitation. So that is where you will observe this. Now, which are the regions of permafrost? Regions of higher latitude, closer to the region of the poles, and even the regions of higher altitude, right? That is, after a certain height, if you go, you will only find permanently frozen areas in very high mountain peaks, etc. Those are the regions of permafrost. But this event is mostly observed in the regions of higher latitudes, coastlines of Greenland, small islands of northern Canada, some portions of northern Europe. That is, those are the areas where you will experience them greatly. Okay. Now, after this, we come to the portion of gradation, but we'll do one thing. We'll initiate the process of gradation tomorrow. So basically, it means not in India. No. Solifluction is not prominently found in India. No. So here, very briefly, I will tell you about gradation, and then we will discuss some of the prelims based PYQs which have appeared from the portion of geomorphology, only those which we have managed to cover till now. Glacial activity is not a solifluction, no. Glacial activity and glacial erosion is different. Solifluction is when the topsoil will topsoil will be moving, right? So topsoil is moving because of the presence of the meltwater. Glaciers are not. They in the case of the glacier, what do you have? You have masses of ice which are moving, isn't it? Now, gradation is what? Gradation is when materials from one region are carried over by the river or by the glaciers or by the wind or by the sea waves, and then they are deposited at a different region altogether. So, for example, you might have a rock or a mountain in this area. Now, you might have a river moving here, river originating and moving from here. Right. Now, the river will continue to erode this mountain here. It will erode these materials. It will then transport those materials, and then those materials will be deposited somewhere, right? So that entire process of erosion, transportation, and deposition, that is what is the process of entire process of gradation, as it is referred to. So it includes degradation, transportation, and then aggradation. Degradation refers to erosion of materials. Aggradation refers to deposition of materials. Now, this can be carried out by the various agents of nature: running water, underground water, glacier, wind, and the action of sea waves. Each of them create their own set of features in the process. And that is something we will take a look into tomorrow. Before that, we'll take a look into the questions, the prelims based questions first. Okay, this is the portion that we have not covered till now. So we'll start with this one. This appeared in the prelims examination this year. In a seismograph, P waves are recorded earlier than S waves. In P waves, the individual particles vibrate to and fro in the direction of the wave propagation, whereas in S waves, the particles vibrate up and down at right angles in the direction of wave propagation. Which of them are correct? Roshan, if you're facing a technical issue, my dear friend, please contact us immediately on the mentorship line or at IES Live. Get that sorted out. Is there any reference point for measuring mean sea level? No, generally an average is assumed. Creep is also formed due to gravity or interior heat. But it is an external event, my dear friend Shyam. It is an external event, obviously by gravity. So here, good. Majority of you have given the correct answer. So in a seismograph, P waves are recorded earlier than S waves. Absolutely. Well, yes, they travel faster. In P waves, the individual particles, they vibrate in the same direction as the direction of the wave propagation, whereas in S waves, they uh, oscillate perpendicular to it. That is why S waves are slower also, and that is why S waves are not observed in the liquid and gaseous medium. So both of them are actually correct. So the correct answer is going to be C, both 1 and 2. Variations in length of daytime and nighttime from season to season are due to Earth's rotation on its axis, Earth's revolution around the sun in an elliptical manner, latitudinal position of the place, and revolution of Earth on a tilted axis. Which of this is responsible for the variation in the length of daytime and nighttime? And Ziba, no. Mass movement does not always have to be fast. Even solid fluxion, for that matter, is a slow movement. Chandu, I'm writing 250 words in a single page. Will it affect me in the mark scoring? No. Because right now, get the practice as much as possible. Good. Majority of you are given the correct answer. So, Chandu, get that practice of writing. Ensure that you write at least 500, 600 answers. Over a period of time, you will take care of the spacing also. And when it comes to the before the mains exam, I I hope that you do appear for the mains test series that we offer, and there you will get that practice in those sheets also. Okay. So here the correct answer, majority of you have given, the revolution of Earth on a tilted axis. That means greater exposure to daytime or nighttime. Okay. Atharv, why not B? Saturday is an extra class, Manpreet. Yes. So why it would be B? If let's suppose you have the sun. Okay. Let's suppose you have the planet moving on an elliptical orbit, somewhat like this. Let's consider the elliptical orbit like this, because considerable number of you had marked B also. Let's suppose here you have planet Earth, but its axis is vertical. Now, if the Earth is present in this location, Atharv, listen to this carefully and let me know when you understand. So here, the axis is vertical. So both the northern hemisphere and the southern hemisphere, they will be receiving equal amount of solar rays, right? As they rotate, duration of daytime will be same as the duration of night time. 12 hours night, 12 hours day. If the planet Earth is here, same event. If the planet Earth is here, same event. If the planet is here, same event. So regardless of wherever the planet is in an elliptical orbit, if the axis is straight, means both of them will receive the equal rays of sunlight. Why do we experience equinox? Equinox, when we experience it in March and September, you have the equal length of day and night. That is what we refer to as equinox. Why is it so? Because at those times, neither of the hemispheres are tilted towards or away from the sun. That is why both of them get equal daytime and nighttime. Here, what do you have? Length of daytime and nighttime, that has to vary. Right? I hope that is understood now. Now, in the northern hemisphere, the longest day of the year normally occurs in the first half of the month of June, second half of the month of June, first half of the month of July, second half of the month of July. This was again a question which was asked last year, I think. Kiran, stages of preparation for UPSC. First things first, get into the basics, get your basics correct. How do you get your basics correct? Read those basic subjects, the GS, the big four. Those big four need to be addressed: polity, history, geography, economy. These four need to be addressed. Simultaneously, you need to pick up newspaper reading. Newspaper reading, understand, you will face difficulty. Initially, you won't be able to understand everything. Slowly and steadily, you will comprehend, right? And that will form your greater understanding of the static portion, basic static portion also. And the third thing that you have to focus upon is your writing. So not always creation of answers will improve your writing skills, because it will be some time before you gain enough knowledge to write good answers. So what should we do? Should we keep down the pen and paper and stare at the screen till that point of time? No. Let's suppose you have read a newspaper article, right? What have you understood about that newspaper article? Write it down in your own words. 50 words, 100 words, 150 words. And Biswajit, this is for you as well. You have asked about how can I write the same thing in 150 or 200 words. Once you understand something and then you have to recreate it, that will give you the flexibility. And that is also a key to important and good answer writing is always understand when you are writing an answer, always think about it. If you have to stretch it out or if you have to bring it to the concise nature, suppose you are trying to explain the concept of plate tectonics to your younger sibling. How do you do that? Do you tell your younger sibling about the aspect that you know residual heat, etc.? You talk about it in very simple terms. Write it down. So that writing practice, once you have there, once you have attained that, so when will you attain that writing practice? If you have understood the concept clearly. If you read multiple newspaper articles, one article you have not understood that well, one article you have understood significantly well, which will be the one which you will be able to reproduce better? Obviously, which you have understood well, that you will be able to produce it in 30 words also if needed, 300 words also if needed. So that is where, depending upon the understandability, the writing skill develops also. Okay. So here, majority of you have given the correct answer. Second half of the month of June, 21st, 22nd of June is when you have the June solstice. Now, consider the following statements. The Barren Island volcano is an active volcano located in the Indian territory. Barren Island lies about 140 kilometers east of Great Nicobar. The last time the Barren Island volcano erupted was in 1991, and it has remained inactive since then. I'll give you a hint. You can use it for elimination. Yes, Deepa, correct. Third, Kiran, is writing, answer writing. Once you have covered the GS, you'll be able to then select your optional also in a much more wiser manner. Yes, Dinesh, correct. Pooja, wrong. Should we make notes from the PPT? Once you have read it, Manpreet, then after that you can try to write whatever you have understood. In the meanwhile, as the lecture is going on, if you can make some running notes, because many of the things that we discuss amongst ourselves, the examples that we talk to each other, and we basically come at certain examples, you guys provide certain examples, I provide certain examples, maybe certain few of the students, they provide an example which you are not aware of, note it down somewhere which you can later consolidate. So that will always be helpful. Now that we are going to start climatology from Monday, that will be very, very helpful. Okay, so the last eruption was basically observed around 2017. So here, Barren Island volcano is an active volcano located in Indian territory. That is correct. It is in the Andaman region. It is not in the Nicobar region. It is in the northern portion of the area. And last time, Barren Island volcano erupted was in 1991. It is incorrect. This is also incorrect. So the correct answer will be A1 only. Okay. So with that, we will end the session here. Tomorrow, we'll discuss the mains type of question from here. So leaderboard I will show before ending the session. So this is the leaderboard. Farufuddin, very good. Suhas, Akhilesh, very good. Okay. So with that, I will basically end the session here for today. We meet again tomorrow morning again for the same time. Until that point of time, do take care of yourself. Goodbye. Thank you for having so patient hearing. And till that point of time, try to revise also. We meet again tomorrow, where we shall be also talking about some portions of map pointing also. And that's all from my side today. Goodbye. Thank you.